Can you hear us?
Hey, can you hear me?
Yeah, yeah. You're yeah, you're audible.
Great. Just a second to share my slides. So you should be able to see a slide now, right?
Yeah, we can see you. You can continue.
Okay, great. Uh, Hi, my name is Andre. Thank you for coming here. I'm seeing some people on the rooms. Sorry for not being able to participate physically, despite the fact I would love to be there. So we'll spend approximately 40 minutes together to talk about how you can find vulnerabilities in a code base using open source tools. And this talk and the backing workshop, as you learn, is called the Open Source Fortress. Some details about myself, as I mentioned, my name is Andre. I goes by Yosifake. I started cybersecurity a long time ago, and I recently failed with a startup for automating cybersecurity solutions. I was a security engineer in the Romanian army, and Canonical, the company organizing this and the company backing an operating system loved by a lot of us, namely Ubuntu. And currently, I'm a security engineer in Snap, the company behind Snapchat. I'm also an open source maintainer, a Google Summer of Code mentor for open printing, and an enthusiast for good coffee, long runs and hikes, and quality time. This being said, let's start with an example. And we'll see Roundcube. Roundcube, which is a browser-based IMAP client. Probably the self-hosting fans over here already know about this platform, but for those of you who don't, it basically provides the full functionality that you can expect from an email client. Basically, you take this open source solution, you install it on a server, and then you have your own Gmail or your own Outlook, which is self-hosted and private, only for you. We can judge the usage of this tool by looking at the stars, and you can see that we have a straight line for the stars on GitHub. And also, if we are using Shodan, which is this search engine for computers on the internet, we can see that we have a lot of hosts, namely over 100,000. This being said, we can also start learning about what programming languages were used in this solution, and this information will be helpful later. We can just clone the repository, change the directory into the folder, and use SSE for counting the lines of each programming language. And we can learn that this solution is using a lot of PHP, a lot of SQL and JavaScript, some HTML, and some shell scripts. The flow that I want to talk about, and this is a vulnerable one because we are talking about security in this talk, is the installation one. So here we have the form in which the maintainer of Roundcube at installation should populate the details of this instance. For example, the product name or the logo that should be put on each page of the Roundcube instance and so on. One specific workflow of this setup page is the following. Basically, we have the user one, which is configuring the Roundcube instance, and this user sends the configuration to the server. Then the server stores the raw user-controlled configuration into the internal configuration state. And then if we have another user which is sending an email with a non-standard image, then Roundcube will try to convert this image from a non-standard format into a format that Roundcube is able to understand. And for this one, it gets a configuration item, namely something that is set by user one. And this path is then used into a roundcube exec function for converting the function, as mentioned before. So we are missing something here. And I don't think you'll be able to provide me an answer, but I can say to you that the answer for what we are missing here is, in fact, input sanitization. Namely, the configuration that is provided by the maintainer of the solution is not sanitized at all. And let's look into how an attacker can exploit a vulnerability in the Roundcube instance. We have the post request, which is sent by the by user one to the Roundcube instance. You can see the method over here, the path, the protocol being used, and the most important part is this IM convert path, which is in the middle of the slide. I don't think you can see my cursor, but there I'm setting a PHP space dash air and then some comments. This is basically launching a remote shell. If then the attacker will send an image in a non-standard format, then the Roundcube will try to convert this image, for example, in the TIFF format, into JPEG. So the command stored in this IM convert path that I mentioned before will be executed. So what will happen is that the attacker will have a reverse shell into this email client. So a full compromise of a server. This is known as CV 2020-12641. And we have multiple items which are unsanitized. And IM convert path that I mentioned before is just an example. It leads to arbitrary code execution, and it has a severity of 9.8, which is pretty high on a scale from 0 to 10. It also has an APSS of 8.12, which is a percentage describing how much the attacker are exploiting this vulnerability in the wild. And this is a number per March. It was also used by APT28 to compromise some Ukrainian organization servers. So it was also used in this kind of tactical environments. And another interesting fact about this vulnerability is that CISA, which is this American organization, also added the vulnerability into CAV, which is the known exploited vulnerabilities catalog. And then the question is, was it preventable? And as you may think, because of the topic of this workshop, yes, it was preventable, but not with standard linters or scanners. And the reason here is that we have some custom functions that are used. You can see in this code snippet that we are retrieving the configuration with this roundcube get instance config get. Then we are doing some basic checks, and then we are returning the comment. And this comment, which is returned, ends up being executed by the server. The reason, as mentioned before, the reason why we cannot easily detect this is that Roundcube also uses some custom functions. So what we can do in order to detect this vulnerable code flow is using taint analysis, which is basically following the program execution and looking for the control data, which in this case, it's the configuration. For example, if we have a Roundcube instance which is exposed on the internet, this configuration can be set by anyone. Yeah, as you may think about, it's clearly a misconfiguration. And we have a sensitive sink, namely a return. So what we can do is, hey, we can trigger an alert whenever we have a configuration item not being sanitized and being returned. For this, as we will see in this talk, we can use Semgrep, which is a partially open source code scanner. And this is how a rule in Semgrep will look like. So we are setting the pattern into the pattern sources section. And then we are setting a sanitizer, which says that, hey, if I'm using escape shell command uh, in the function before doing the return, then we don't have a vulnerability. And we are also setting the sync, which in this case is just a return. And we are also setting the severity of this rule as an error. If we run that rule that I presented before on the function being presented before, we can see that we have two matches on these two lines. So if we are creating the rule and we have Semgrep and we have the code base, then we basically identify two potential vulnerabilities. And if we would have been a Roundcube developer, this would basically prevent the vulnerabilities, namely the CV, which I presented before. This being said, uh, I want to present you something called the Open Source Fortress. It's publicly available on ossfortress.io, and it's a collection of tools that can be used to proactively detect vulnerabilities. It's meant to be a workshop, but in the context of this conference, it will be just a talk. So we'll present only the vulnerability detection techniques, which I usually describe when having the workshop. As to the structure, there are multiple categories, and we will tackle only the bold ones, namely some high-level details about software security and a brief presentation for each analysis technique. And we will see some practical example for analyzing a vulnerable code base. But at this moment, let's tackle the elephant in this room. And this is the question, but why open source? If the companies or the organization already have some paid products, it's really nice to have a second layer of security. So if there is something that the paid product will miss, then we will have another solution that will look at the same portion of code, and there is a higher probability that this combination of two tools will detect something, a probability which is higher than just running the tools alone by themselves, uh, only the first one or only the second one. If the organization doesn't afford having some paid products, they are really good as a replacement. As you'll see, these are major products, major open source projects. So you can basically just download them, run them, configure them, and that's it. You'll start having results. And it also lowers the engineering efforts when compared to building some in-house solutions. And this is also because we have the default configuration collaboration, which comes with open source. So if we have one organization publishing some new static analysis rules, let's say, then other organizations will be able to fetch these rules and to use the rules inside their organizations for their code bases. Let's talk a bit about the usual vulnerability detection process. These are techniques which we will tackle in this talk, but usually we start by having a threat model. We'll see what this is, but this entire process will produce a threat model. With this, we can start doing manual vulnerability discovery, then, for example, looking at the code by ourselves and trying to see some vulnerable lines of code, or we can just use some automated vulnerability analysis. And a process that I recommend here is to run multiple tools, have the results eventually in the Sarif format aggregated. We can triage them, we can validate them, and in the end, we will have some vulnerabilities. And these vulnerabilities are the common denominator for two other types of activities that we can do afterward, namely some defensive activities or offensive activities. For example, if you are part of an AppSec team inside an organization, then you'll do the defensive one. If you are a red teamer, for example, and you want to prove your impact with this vulnerability that you discovered, then you will follow the items in the second slide. But let's firstly talk about the defensive ones. We can do vulnerability research. So we have, for example, a warning which is reported by a static analyzer. Then we deep dive into what the vulnerability assumes. We can do a CVSS approximation to approximate how impactful is the vulnerability we discovered. We can classify the vulnerability using something called common weakness enumeration. We can request a CVE ID. And after finishing this vulnerability research, then we can start doing the patching work, namely fixing the vulnerable code from our platform, from our code base. And after having the patch, we also have the communication with the stakeholders. For example, we can send them emails, we can post some blog posts onto our websites and so on. You'll have access to these websites. These items that you can see here in blue are clickable links, so you can basically see some examples afterward for Log4Shell. Talking about the offensive activities, which I mentioned before can be executed by some red teamers, you can think about some exploit writing. Namely, we have the vulnerability, then we try to create an exploit which will trigger the vulnerability and will make us have some privileges which we usually don't have. For example, accessing some files or executing some code. And here we have an attack vector, namely how we can execute the exploit. We can have a bypass mitigation, and also you have here some clickable links that you can use before afterward, and a stage for weaponization. Namely, we have the exploit run. Then let's start thinking about what we can do. We can delete some files, we can create a new user into the system, and so on. After we have the exploit writing, we can start the exploitation, and that's probably it. We successfully demonstrate that the vulnerability that we discovered is indeed impactful. Having this in mind, I mentioned to you that there is a vulnerable code base that we will use for this talk, and this is Sandcastle. It's a vulnerable by default code base, which is indeed open source. And as a description for this one, it's a lightweight piece of software that runs on a Debian-based server and allows users to control it to their browsers. And you'll see in a demo afterward how it looks like. It's also an on-premise deployment. So if you have, let's say, an Ubuntu server, you can install this vulnerable piece of software on the server in order to access your files or run commands on your browser. And another relevant piece of information is that it's written in Python and C, and it also embeds 12 vulnerabilities. To give you a brief about how does it look like, it's like this. I'm using some credentials for logging in. And after that, I have multiple functionalities. And here I'm demonstrating how can I upload an archive on the server. So I selected the archive, I uploaded it, and then I can see where I am inside this command executor. And then I can list the files that I have on the server. In this case, the path /home/ubuntu/archive. And I can see the file that I had in that archive. As an architecture, we have a web UI, which is communicating with a web API, which is built in Python 3 and Flask. And there are multiple modules which are helpful for this backend, namely the recovery token module and the Linux authenticator. And let's start with the first vulnerability discovery technique that I want to approach, namely threat modeling. You can see in this picture what threat modeling look like. You can think what is the asset that you need to defend, which in this case is the food. You should think about the threat to our asset, in this case, the cat. And the threat modeling process assumes being inspired enough to assume that the cat will attack when we will have the fridge open. So the process, theoretically speaking, means that we need to identify the assets, namely the food from the fridge, and the threats, namely the cat. And these are the questions that you can use when having a code base to think about the assets and the threats. And it's interesting to think that this threat modeling process, which is applied for any code base, is also a really good requirement in the USA and Singapore. So some states are doing efforts into making this process mandatory because it helps the security engineers and the developers discover vulnerabilities before pushing them in production. The first open source solution that I wanted to talk about, and in this case for threat modeling, is OWASP Threat Dragon. Having in mind the vulnerable code base that I mentioned before, namely Sandcastle, you can see that we can use the Threat Dragon to model that solution here. And we can see the same elements as before. Namely, we have the web UI, we have the web API, and the other systems that I mentioned, the Linux file system, the authenticator, and the recovery token module. And having these assets, we can also think about the flows between them. In this case, I detailed the one which are happening between the web UI and the web API. Let's say I'm choosing the login, and I need to start thinking about, hey, how can attacker do something with that flow? And in this case, I can basically select into OWASP Threat Dragon that specific flow that I designed, and then I can select here the threats, namely how the attacker can attack that. So this threat modeling tool is developed by OWASP, and the usual process consists of creating a threat model, creating a diagram. It permits using multiple models, for example, Stride and CIA. You need to represent your assets, and there are multiple types of this kind. We have stores, we have processes, we have actors, data flows, and trust boundaries. And we need to do some manual thread identification, namely thinking what are the threads that we have for the assets that we represented. And we can also set these metadata which are listed on the slide. The next vulnerability detection technique that I wanted to present is the code querying one. And maybe you can make an analogy between the querying part and this screen from Matrix, the popular movie. Code querying assumes that we are searching for a specific pattern into our code base, and it optionally uses a representation for the code base. For example, an abstract syntax tree or a control flow graph. We also have multiple types of queries that we can do. For example, literals. This is something that you are doing, for example, in Visual Studio Code when you are trying to find all the instances of a call to scanf. You also have the regexes. So I'm trying to find not only the name scanf, but also the parentheses and something in between, and data structures, which are specific to tools specialized on code querying. In this specific case on the slide, you can see the query for Journ, which is an open source tool for code querying. So I'm trying to find all the methods which are called scanf or with an I before, and the calls to this function. And the nice part about these open source code querying tools is that they also have community queries, which are quite generic but really handy. Think about the example that the use case that I mentioned before, namely, if an organization will create a new rule, then it will publish that rule in the open source space, and another organization can use the rule. So the same happen here. If I have an interesting code query that I'm using, then I can publish that on the open source space and anyone can use it. This is a representation of an AST, namely an abstract representation of the code base that the code querying tool is looking at in order to find specific calls or specific code constructs we are interested in. And the open source tool that I wanted to mention here is Semgrep. Here, I also included some installation guide. In this case, it's just a pip install, so you can do this immediately after the talk to test the solution out. And here we have a rule for detecting all the calls to a logging function, which also have this password and token arguments present. So I'm trying to find some secret leaks inside the log files. After I have this rule written, which is in the YAML format, then I can run Semgrep with the scan argument, which is basically describing the action that I want to do. I'm specifying the format in which I want the solution to output, which is the SARI format. I specify the configuration in which I store the rule, which is the YAML one, which I mentioned before, the output file, which is this array file, and the code base that I want to scan. In this case, I have a format now named codebase sandcastle inside my home directory. After I execute that command, you can see that I have 17 files scanned and I have 9 findings. And one of the findings is this one. So you can see that I have a piece of Python code which is logging the credential of a user when he or she is trying to authenticate. So an attacker, for example, having access to the file system will be basically to retrieve all the credentials of the user, which in fact is a vulnerability. Semgrep, as mentioned, is a partially open source code scanning tool. It supports a lot of programming languages. So if you are using any popular programming language, there is a high chance of Semgrep supporting it. A huge advantage for Semgrep is that it doesn't require a build before. Uh, think about just fetching an open source project in C from GitHub. Uh, we may end up having some build issues, which prevent us doing some advanced analysis techniques. So Semgrep is really helpful because we are just cloning the repository, we are writing some rules, and or we are using the community one, and then we are just able to analyze it. We don't need to be able to build the code base, which, as in the case for C or other programming languages, which are more low level, it may be a bit harder to do. And there is also no domain specific language that we need to learn for writing this rule. As you have seen before, it's just plain code in Python. And another advantage is that it has default rules. So we can scan a code base just by downloading the executable for Semgrep, or we can use third-party ones. Another classic movie, right? Any guesses? Yeah, it's Idiocracy from 2005, in which people are dumb enough to use the brute force to solve a childish game, right? To match some shapes in and some holes. And uh, this brute forcing technique is also used for scanning software inside something called fuzzing. And this assumes that we are running a program multiple times and we are offering random unexpected inputs to the program. In most cases, a crash is a security issue. So if the program that we run with a random input will crash, then it may be something interesting there, and we may end up with a security vulnerability. And a crash may mean a dereferencing for a null pointer, may mean a sanitizer, which can be ASAN, UBSAN, and so on. And uh, you can think about fuzzing as a BFS traversal of the control flow graph. There are also some optimizations that may happen, but we don't have time to deep dive into that. I just wanted to also show you the architecture of a usual fuzzer. Um, and as a practical example for the vulnerable code base, we have AFL++ that can be used for detecting vulnerabilities through fuzzing. We just fetch the Docker image, which is AFL++ as slash AFL++, and then we can use it with the exec command and bin bash. This is a main program that we can use for fuzzing. We are basically reading the file which is provided as an argument, and then we run the generate recovery function, recovery token with the data which is embedded in the buffer provided by the fuzzer. If we run fl++ using this command, which is specifying the usage of ASAN, it's including the debug symbols, is specifying the output file, the source files over here, then we can start fuzzing, right? We have the inputs, we have the outputs, we have the binary, which I mentioned before and built before, and then I'm using the syntax to specify what is the file that needs to be fuzzed. And then FL++ will show us this interface with useful information when doing the fuzzing session. And in the end, we can discover a vulnerability over here, which is in this malloc and in this string copy. If we are running the commands which I mentioned before with the vulnerable code base, which is available on GitHub, you'll be able to discover a vulnerability in this code base on the strings copies over here. So FL++, it's a fork from a classic fuzzer that we had in the open source space, which is American Fuzzy Lab. It has additional features compared to AFL, which assumes QEMU emulation, persistent mode, and other optimizations. And it's also embedded into Google OSS Fuzz. If you are participating in the second talk that I have on this track, you'll learn more information about it. But it's a community maintained fuzzer that Google provides to open source projects. Another vulnerability technique that we can talk about is secret scanning. And this assumes that we are searching for secrets into our code base. And the secrets may be API tokens, maybe credentials that we hard-coded into the code, or tokens. We are searching for these patterns, or we are searching for entropy of a secret. For example, the code that we are writing usually respects the entropy of the English language, right? So if we have a random token for 40 characters, let's say, then the entropy of that specific code portion will be higher, which is an indicator for embedding a secret. It also has community rules, which we can use to detect some secrets that we embed. For this practical example, I have git leaks. You can just download the binary from the GitHub releases, and this is the command that we need to run for detecting secrets into the Sandcastle vulnerable code base. I'm specifying the detecting action. I want the serif to be the report format, and I'm specifying the source, uh, the report path, and I'm mentioning this redact parameter. Sorry, I'm seeing a 1. Is that the remaining time or? Yeah, I'll just continue. I cannot hear. So if I run that command on the code base,
Yeah, hello. Please try to finish in 1 minute.
why is this?
Okay, so both of your talk is scheduled till 4:30, I guess. So
But we
try
also
to
had a
finish the
2 hours delay in the beginning, right?
yeah, try to finish your first talk in 5 minutes, and then we'll start with your second talk. Okay.
Okay. So by running the command that I mentioned before, I can detect 5 leaks into the code. And here is just an example of how an embedded secret will look like. In this case, a hard-coded secret key into Flask. So GitLeaks, the tool that we've looked at, is a detector for hard-coded secrets. It also analyzes the entire Git history. For example, if you are developing using this kind of version control system, then you may have some secrets which are overwritten. Uh, so if this secret is overwritten, if we are looking just at the latest version of the code, a usual secret scanner will not be able to detect it, but GitLeaks will be able, because it will also be looking at the history of the Git repository. And it also supports baselines and custom formats for secrets. I don't think we'll have time to look at all the slides, so I'll skip starting for now. There were multiple sections for dependency scanning, linting, and symbolic execution, but you'll have the slides afterwards, so you can deep dive into that, and you can also ping me afterward if you have any question. Rad, Outside of these techniques, we also have stress and load testing. I recommended you here some open source tool that you can use, for example, JMeter and K6 for many protocols, or Kubernetes in the case for K6. We also have web dynamic analysis, and probably some of you are already familiar with ZAP. And if we start to think about automation, we have Serif multitool, which is able to operate on the Serif files that we were using inside this talk. We can run some tasks using make and poet. We can have IDE workflows for running the tooling in our preferred IDE, for example, Visual Studio Code. We can have pre-commits, which will be able to run the code scanners before making a commit into the repository. We have AST and GitLab runners for running CI/CD workflows locally, and GitHub Actions and GitLab pipelines for running CI/CD workflows remotely. Maybe some of you don't know about it, but the Ubuntu keyword doesn't mean only the name of the operating system, but also a concept of the Southern uh, African philosophy. So there is this quote from Nelson Mandela that I really like, and I think this embeds the idea of open sourcing. Namely, Ubuntu does not mean that people should not address themselves. The question, therefore, is, are you going to do so in order to enable the community around you to be able to improve? So in the end of this talk, I just want to briefly mention some ways in which you can participate with your security knowledge to the open source space. Firstly, you can do some security focused work. You can create a threat model for a code base. Not many projects have the time to invest to create a thread model, so uh, I assume that going to a random project on GitHub, any popular one will end up you having some work to do because they will not have this kind of artifact for them. You can do a security review and report the findings that you have. You can implement new security mitigations for some open source projects. You can propose some patches for some vulnerabilities which were not patched before, or you can also backport some patches because the maintainers are usually patching only the latest version, not all the versions that were available in the past. And you can also create some new workflows for security scannings. For example, just take Semgrep and push some GitHub automation into an interesting project that you have on GitHub. And for the most popular open source projects, you can also embed them into OSS Fuzz for scanning them continuously. Another way to support some open source projects is to just give them a star. It's just a sign of appreciation for the maintainers. You can share the project with your friends and followers, for example, or on Twitter or LinkedIn or anything that you are using. And you can also write a short feedback email to the maintainers. Usually they don't receive a lot of feedback, so any of it will be really helpful for you. And in the end, I'm sure that they will be really grateful for your work. If there is a single thing that I want you to remember after this talk, I know that it was a lot of it and we didn't manage to cover it all. You should remember this URL, which is for the workshop. So if you are interested in doing some practical work and to explore these open source tools that I mentioned into this talk practically, then just enter the website, clone the Docker infrastructure locally, and start working on that. Yeah, so this ends up my first talk. I'm happy to have any question. Let me stop the presenting by now. Is there any question in the room that I can address?
Can you hear me?
Yeah, I think so.
So right. So during your during the section of your presentation that was about automation, you mentioned make and code the poet for running tasks. So
Yep.
could you elaborate more on what those two tools are? Well, I've heard of make, but code the poet, I guess I'm hearing for the first time. So could you elaborate on more on what those tools are and how exactly they, you know, help?
Uh, I cannot hear the question. There is a lot of echo. Can you request the people over there who are organizing writing the question of the on the chat? I heard the automation part, the poet and make, but I didn't hear the last part.
Switch off है. Switch off क्यों हुआ? Hello.
Yep.
Henry, are you able to hear me right now?
Yeah, yeah, it's better.
Wait, the person who is asking the question is with me. You can speak.
Yeah,
I'm writing. It's fine.
It's fine. Okay.
yeah,
Okay, he's writing.
yeah. You can also say it right now because I'm clearly hearing you.
Okay, okay, sure. Did you got the question?
Yeah, yeah.
Okay.
So I was mentioning these specific tools because they are generic for automating some tasks. For example, if you have some unit tests that you need to run, then you can also use these tools in order to run the command that will trigger the unit tests. So what I was thinking about when I implement these tools is to embed, for example, Semgrep and a dependency scanner and a secret scanner inside your make or Poet environment, and you'll be able to just run POE and the configuration file and the tools which are embedded in the POE and make configuration will be automatically run. So you'll be basically able to use the same commands into multiple environments. So you'll use the same command in your Visual Studio Code environment. You'll use the same command for your CI/CD environment. You can use the same command for in your Git commit. So you'll basically shorten the command that you should run. There is just an indirection level, and when you're doing a configuration change, the configuration change will basically propagate to all your environments in which you are running the poet or make. Does this answer your question? I don't know if the person
Yeah, yeah,
answering. Okay.
yeah. He said yes. So, Henry, can we like do it a little bit fast because we are running out of time, literally.
Yeah. Should I go to the next one?
Yeah, shall we proceed, please?
Yeah. Just a second.
Thank you.
No worries. Um, just a second to take some water.
Like we need to wrap up the session at 4:10 maximum.
Sorry, can you repeat that?
Like we have to wrap up the session till 4:10 at max.
At which hour? Sorry.
Hello.
Can you repeat that?
Uh,
Hello. Actually, we need to wrap it up by 4:10. अच्छा पूरा
Let me check what hour is that. So locally for you is 4:03, right?
yeah, like in 7 to 8 minutes. Can you wrap it up?
The next presentation or this one?
next presentation.
Uh,
Isn't that for 15 minutes or?
the next presentation.
Okay, I'll try to do that. I'll be short.
Okay.
Can you see that?
Wait a second.
Can you see this slide? Now
Yeah,
it's loaded.
yeah,
Okay.
yeah. It
Uh,
is visible.
Great. So I'll try to be short. In this second talk, I wanted uh, to detail how the open source maintainers can secure their projects. Maybe some of you have open source projects in the room, and I hope this will be helpful for you. I will skip this part because I guess the same people were in the room before. And I will just say that I really think that this meme is really embedded into the reality, namely that we have a lot of infrastructure, both private and public, which is based on these random little projects that we are not aware of. And I'm really sure that a lot of them are also open source. We have a lot of advantages for doing open source work. We have a large scale use in profitable companies and critical infrastructures. The code itself is usually published under permissive licenses, which means that anyone can use that code for any use case. And we have publicly reviewable code. So if a company decides to use a specific open source library, then some security engineers inside that company will be able to investigate the code. But there are also some disadvantages for this approach of open sourcing. We have unpaid maintainers. We have some unmaintained and vulnerable projects, because no one is able to invest any more time into maintaining that or to patch the vulnerabilities. And we also have a lack of security professionals investing the time into doing the vulnerability discovery work or patching work. And this being said, there are really low hanging fruits for the threat actors because they will be able to investigate the code and to detect vulnerabilities really easily compared to having just a binary. I really like this idea from aeronautics, namely standard operating procedures. These are just some steps that the pilots or the crew of the airplanes are following when doing a flight, before it and after it. And I want to take the same approach for this securing of open source projects that I want to present. We'll have some notations in the presentation, namely one-time activities, recurrent activities, and some activities which are familiar, which are friendly to closed source projects. The first section is for finding vulnerabilities, and the one in the room who also participated in the previous talks already have an idea here of what they can do. Initially, they should create a thread model, and we have seen what this means. This is a screenshot from the Threat Dragon open source solution. Secondly, you should check the dependencies inside your vulnerabilities. This is a plot for the dependencies for the discord.js API library, which is published on NPM. You can start thinking about a scenario in which I have a vulnerability over here. What will happen? Will Discord.js will also be vulnerable? And the answer here, it depends, because the code from here there is a chance of this code not being triggerable at all. So for this one, we can use a dependency scanner that may also support some reachability analysis. And in the end, we can detect this vulnerability and we can patch them accordingly. The third recommendation that I have in this section is to run the security tools and to continuously validate the warnings. Here we have multiple steps. We can run the tools, we can aggregate the results, we can review the results and suppress the false positives, namely the warnings which are not indeed a vulnerability. And as described in the previous talk, we can create some automations for development environments and CI workflows. And for the projects which are really critical for the internet infrastructure, we can also embed them into OSS Fuzz, which is an open source solution published by GitHub and maintained by them, which is continuously fuzzing these projects for detecting vulnerabilities. This is an overall infrastructure for OSS Fuzz. If you attended the talk in the morning from Jongshu, then he basically described what happens inside it. The second section that I have is for securing your users. And here you should start designing the software with a secure by design mindset from the start. An implementation of this was inside Chromium. which enabled few years ago the HTTPS by default when you are typing an URL. This is a small change, but it's really impactful for the users because they defaultly accessed the HTTPS versions when typing something, not the HTTP one, which are prone to wiretapping attacks. You can also have security recommendations for the users, and this is a screenshot for what the Node.js ecosystem is doing, namely having a security best practices guide and creating SBOMs, namely software bills of materials, which are these JSON files which are describing the dependencies, their versions, and this is really helpful for the people looking into vulnerabilities in the dependencies of this code base. You clearly know what other code was used when building the software that you try to fetch. And the last category here is to create a security reporting process, initially by having a standardized documented process for responding to vulnerabilities. Node.js is also doing this great. They have this detailed process of how this can be achieved. You can also create a security policy. In the case of open source project hosted on GitHub, you should just create a security.md file with the recommendations that you have, or how a security researcher can detect a vulnerability that they discovered. And lastly, we should also think about having some backup security responders. Namely, hey, if I have one security engineer here, and he or she is in vacation, then what will happen? Who will respond to the security issues that are reported? And the Node.js ecosystem is also doing this great. They have a team of 5 people which are doing this continuously. And another extra is to be transparent and verbose in the vulnerabilities that you report, because as you may know, there are a lot of fields which may be published when reporting a vulnerability. Just a short mention about what I presented before, the open source fortress. It's a workshop for finding software vulnerabilities using open source tools. Uh, as looking in the room, there are the same people, so you are already familiar with this. I'm just mentioning the links to the GitHub repository and the wiki. And yeah, that's probably it. If you have any question, or if you just want to connect, just scan this QR codes, you can find me on LinkedIn. So we can continue the discussion over there. Yeah, I guess that's the speed run of this presentation. Is there any question in the room?
Hello.
Yep.
Yeah. Thank you, Henry, and thank you all for your participation. It has been a pleasure having Henry with us today. We are grateful for the time and knowledge you have shared with us. So let's give a huge round of applause for him.
Thank you.
Okay. Thank you, Henry. Thank you.
Bye-bye.
Bye.
Hello. 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 Are you both able to hear me? Sorry, your voice is not coming. I'm sorry, Patrick, I'm not able to hear you. Wait. Yeah.
Test 1, 2. Test.
Yeah. Uh,
Test
yeah,
1,
we are
2.
able to hear you now.
I understand you.
Okay.
Test. Josiane, est-ce que tu m'entends?
Oui, est-ce que vous m'entendez?
Moi, je t'entends, mais eux, ils semblaient pas m'entendre, puis je l'entends, lui.
Ah, c'est drôle. Puis, est-ce que...
Do you hear me?
Yeah. Yes, Patrick. Yes.
Okay, good.
Are you guys
Thank you.
able to see the audience?
Yes, good. Yeah, we see the audience.
Okay.
Perfect.
Sure.
Good.
So now I invite two of our guests, Hussein
Donc,
Marcel
toi, c'est toi qui projettes, Josiane, ou le PDF?
Comment je fais ça?
PowerPoint?
Sorry, are you able to hear?
Présenter diapositive. Vous n'avez pas de diapositive.
Patrick, are you able to hear me? Josephine also.
Yes. Hello?
Are you able to hear? Are you able to hear me?
Yes, oui. Es-tu capable de l'entendre?
Yes, I can hear you, yes.
Okay. Okay, so let's start the... Hello?
Yes. Are you able to start the PDF files, or you have to do it?
Can you share the screen of yours?
Yes, I will.
Okay.
Okay. Fenêtre. This one. Do you see it?
Yes. Wait.
Perfect.
Yep.
And can people see us and the presentation, or only the presentation?
Yes, they are able to see you.
Okay.
Good.
Okay. So you both can start your presentation now. The stage is all yours.
Thank you so much.
Thank you.
Hello, everyone. It's very early for us. It's the end of the day for you, so we'll try to be active and dynamic. We are in Canada, Patrick and myself. Patrick is a PhD candidate at Université Laval in Quebec City. I am a professor and also the director of the thesis of Patrick. I'm Josiane Marsan. I'm a full professor in information systems. Both Patrick and I have a technical background, so we are both informaticians, computer scientists. We did program and do design of systems in the past, but we took the path of the business school, Faculty of Business Administration in our case, FSAU Laval, to do research and teaching more about, we'd say, the soft or the organizational side of information technology and open source software, because it's our expertise. And I was involved in the proposal for getting a grant from government of Quebec and the European Foundation for Research, let's say like that, INRS, in collaboration with professor in software engineering in polytechnic schools in University of Mons in Belgium, Tom Mens, also Bram Adams, maybe that you know. They are well known in the open source community as very good researchers. Bram Adams, who was at Polytechnic Montreal at that time, now is in Ontario. And we also involved in this grant proposal Kevin Carrillo from Toulouse Business School in France. And we were really happy to get the grant. And it was really about not corporate involvement or social responsibility at that time. You will see how it evolved. But it was about the health of open source ecosystems composed of IT projects and their communities in open source. And because they realized in the field that there are sometimes difficulties, problems that can arise in the projects and communities that can really affect their health. And we were using a metaphor of an ecosystem, a natural ecosystem in the environment to try to understand those problems and their causes. So that's where it all started. But before going to that, I also did my PhD in HEC Montreal, a business school. And when I talked about doing research about open source at that time, it was 2005 when I started my PhD. And at HEC Montreal, professors were like, oh, no, open source software. Oh, that's weird. Oh, that's something that we don't really know about. Is it a good thing? Is it a bad thing? You know, it was difficult at that time to have people understand what it was. And in my job as a programmer, I was using open source software library all the times. We developed an enterprise resource planning system, an ERP, from scratch, using open source software for a mid-sized company in Canada. And so I was really interested about open source software, and I saw a lot of opportunity, to use the term of the conference. And I was very sad that I could not do my PhD thesis about open source projects and communities and the adoption of open source software in organizations and in general, because I saw that some organizations were starting to adopt it in Canada and some were really afraid. And that was something that I wanted to study. And at some point, I will go to the next page. At some point, Brian Fitzgerald, which is also a researcher in IT. Probably you know him. He's published a lot about open source software in software engineering journals and conferences, but also in information system. So he's really, I would say, a technical and business researcher. And in 2006, he published in our top journal in information system for researchers, which is MIS Quarterly. He published an article about the transformation of open source software. And of course, you know, there is also the Free Software Foundation, and there is the OZ, who came later to say that, okay, we should have a more commercial friendly approach to free software. And it all began there. It's where we really started to hear about the phenomena, because they were a bit fighting, the FSF and the OZ. So Brian Fitzgerald said, indeed, in 2006, we can say that free software has become more commercial. It has metamorphosed. It's becoming mainstream. But he also said in this article that there will be challenges in achieving a balance between value for money for corporations that want to take opportunity of open source software versus the community values, because at that point, most of the open source projects and communities were volunteer based. They were funded by volunteers. Volunteers were participating, and it was rare to see companies really involved, and especially big companies. So that was the thing. This article, I brought it to my advisor at HEC Montreal, my PhD advisor, saying, see, there is something there, even if we are in the business school, we should be interested into open source software. That's something that is there to stay in, and we have to understand that, and we have to study, and we have to help organizations to understand what it is and what are the do's and don'ts with open source. So I was really happy, and I said Brian later when I met him in a conference that he had changed my life, because at HEC Montreal they started to say, oh, okay, let's look at that, and yes, you can do your thesis, your PhD thesis about that. So I was really, really, really happy to be able to do that. So as a professor, now I have myself PhD students. Patrick is one of them. And when he came in my office saying, oh, my current PhD advisor, unfortunately is sick. I need to find someone else because now it's been too long since she's gone. I said to him, well, I have a Seco Health project that I have funds that I can give you grants to study open source software ecosystem health. And Patrick decided to join the team. And now he is finishing his thesis, probably this year, we hope so, or in 2025. And today we will present you the Seco Health project, and also the thesis of Patrick, a part of his thesis, because there is one article, it's a 3-article thesis, and there is one that we won't present today because it's not really relevant. So, Seco Health is, as I told you, a multi-university international project. It was backed by the Linux Foundation. It was also linked to the Chaos open source software project that you can participate in. I think it's still active. I haven't looked recently, but they are developing a software to measure and monitor the health, different health indicators of open source projects, communities, and ecosystems. And for our point of view, in the Seco Health research team, who are involved in this case for this particular study, because there was many study in Seco Health, but this one, Bram Adams were there. He was the co-principal investigator. Mathieu Templier, professor at Laval University, Kevin Carillo from Toulouse, and Georgia Mopenza, who was a master's student at that time, and Patrick, who was also starting his PhD. And the research question that we had for this study is, what are the most important health problems? And again, health is, any problems, technical, socio-technical, social problems that an open source software ecosystem could have. So those health problems in several interrelated open source projects and communities, what we call them ecosystems. What are the problems that they encounter, and most importantly, what are the causes of each of these problems? Because you can know the problems, but if you don't know the root cause, the deep cause, you cannot address the problem and solve it. So we used a technique that is very known in especially business analysis. When business analysts try to understand the problem, we use the root cause analysis, and we interviewed In this case, I think it was based on 10 interviews with what we called open source software experts. So it's any contributors from the coder to the community manager in an open source software project and communities. We met them at the Open Source Software Summit in Prague. I don't remember the year, maybe Patrick will remember. We interviewed with them. So it was about 60 minutes interviews with each of them, asking them, what are the problems that you have seen, that you see currently in the open source software projects that you're involved with and their communities. And so it was really, really thick description of problems and their causes. And we took it all together. Everything was anonymized, and we put the data all together, and we looked at, and you see that by the color of the causes that are in oval, it's factors that are more or less coming up in the interviews. So if you look at conflicts in communication between contributors, it's really dark. So this one was mentioned by a lot of experts. And the more they are clear or pale, the less they were mentioned. So one of the causes of the problem of loss of contributors, when you have contributors in a community, in a project, and that suddenly people start to go away and they leave the community and the projects and they do not contribute anymore. That was a problem that all of the experts mentioned. And one of the reasons for that is forking of the original project or emergence of more attractive projects that the contributors go to. The most important cause of those two sub-problems, I would say, are implication of company with a lot of resources. So when a company with a lot of resources is involved or start to contribute to influence a project, then it can create the problem of loss of contributors. So we were like, oh, okay, we are business school researchers. We should look at that because we don't want business to create health problems in open source software projects and communities that are really useful and that is gaining attraction in the organizations, and more organizations are using open source software and depending on open source software. So we want the projects to stay healthy, and we don't want other organizations to create problem, or even a client organization could create problem by its involvement. Of course, it can create a lot of good also. It can help projects, it can create code, it can be the manager of the community, and it can be really good, but sometimes it can go really, really bad. So we said, okay, let's look at that. And that's when we started really to think about Patrick's thesis, saying, okay, we're going to look at corporate involvement in open source software communities and how it can create problems. So we were really looking at this root cause that is the implication of company. And we didn't look only at those with a lot of resources or big companies, but any companies that is involved in open source software projects or community. So Patrick, I leave you the stage.
Good. Thank you very much, Professor Marcin. In those researches, we continue to explore all the literature about the involvement of companies in open source. So we found this very good model about the level of implication. So from 1 to 6, 6 uh, where the higher degree of implication of a company, we are now able to see more about how much a company can be in open source project and open source communities. So for us, the big thing is that what we want to see is more about the level 5 and 6, where companies participating in OSS projects led by sometimes a community already, but sometimes it's the level 6. The companies begin becoming member of OSS communities and a part of uh, the communities. So we investigate more in that part of the corporate implication. So this led to us to the study number 2. Josiane, if you can change the slide, thank you. Um, like Professor Marsan said, we met open source experts at the Linux Foundation's events in Europe and US, and in the interviews we read several examples um, where as a result of certain company action, open source communities found themselves in a weak position after all the action. So we want to know more about how the collaborative relationship between company involved in OSS projects and communities can go from, like you say, like you see, harmonious to conflictual, uh, to the point to have a negative impact on the project and community. So we are more looking for not in the IT part, but like Professor Marsan said earlier, more the project itself and the communities, because we want to look at the sustainability, the well functioning of the project and the community. So this research continue, and we found in the results some good example, like you can see right now, uh, really facts about actions from companies to open source community that, like I said, put the community in a negative situation in the relationship. So the first one is more about a company who are very involved, and it was a good thing at the beginning, but at some time stops to contributing to the code, uh, and place the community in a weak situation, because a lot of line of codes depends of this company and the project. Sadly uh, become to be very difficult to maintain by the developers. So led to the project to be in a bad situation. Another example, it's like a company. We met the director, and he need more capacity, so he hired one by one each person in the OSS community. So I think you know the end. At the end, there's not a community; it's more a company who hires all the developers. So they realize after that they lose a lot of creativity and openness about this, because the OSS project are now more a company project, with not an open source community with volunteers. So other example we found in our discussion with the expert, it's a situation like the company uh, really do really like the product, and at some time in the roadmap want to take control of the open source project and the direction, and uh, uh, which feature we will develop and what we will do, and the open source community who start the project was very frustrated about that, and uh, so a negative relationship due because of that situation. It's more the company like Josiane showed, inject a lot of people, so it was difficult for the open source community to fight this power, this power of a big company to keep their roadmap, uh, what they want about this project. So we found a lot of actions like uh, the three I was talking about. To be and want to expose that situation because it's real, and sometimes good products and open source software uh, going to be stopped and fork because of that situation, and uh, we don't want that, but we want to, like researchers, want to understand uh, what in the life of the project uh, uh, we went that far in the conflict. So if you continue, Josiane. So this we want to continue in that way. In the next study, the number three, it's in progress. Now that we understand more about the situation and want to expose those situations, um, we want to go more in I don't know, in a concept article to raise awareness among stakeholders, company, government, and communities of the importance of the open source community in our software ecosystem. So it's one thing to find to discover the problems in the second study, but in this one we want to like I said, raise awareness about this situation because open source community are really present and really important in our digital society. So we have to work with them better if we want to have more, uh, how I said, more well-functioning open source projects. So um, we are looking for in that, like we said, uh, uh, in level 5 and level 6 of the implication. So the sessions when where the company are really involved, and like in study number 2, uh, continue to to looking for situations going harmonious to conflictual. Uh, but to analyze that, we want a new lens to do it and to um, propose some avenue about this, and we suggest to use a, a new framework like it's corporate digital responsibility to very understand and to add the stakeholder OSS communities. Uh, we saw a lot of models with a lot of stakeholders, but we don't know why, but we are looking for that. OSS community are not really often represent like an entity to be aware of, not to be aware of, to take care of. Sorry. Uh, so we want to highlight this part of our, like I said, digital society, where OSS communities are really important. And if we want to have good project in open source, we need to take care of those communities.
And maybe I can add that we not just want to raise awareness, but we also want to make sure that the companies really incorporate this stakeholder open source software communities in their corporate digital responsibility statements. And it all started with corporate social responsibilities, where companies started to say, oh, yeah, well, our actions and our business activities can have influence on and impact on the environment, on the communities of people that our plans are hiring or that are living near our plants. There is a lot of facets in corporate social responsibility that companies started to talk about, and to have statements saying, okay, we will take care of this stakeholders, this stakeholders, this stakeholder, and we will take care of them that way, and this way. So it's really like a document that they produce. Some people may say that that's sometimes it's greenwashing, or it's it's not true, and they just want to look good. But I think that if they do it, at least some of them will be aware and will be sincere into that, and people who wants to have jobs in companies can at least look at that and say, okay, well, maybe they are sincere, and they are really aware, and I share those values, and I'm gonna join this company. As we do with open source software communities, and we look at, okay, what's the roadmap, what's the mission of the project, and how does it goes, and are they a responsible community, and we join those community that we think we will fit in. So with the corporate digital responsibility, it's to think about uh, all the activities of the companies that involve digital. So the development of their software, the selection of the software that they're not developing in house. So all the digital activities, they have an impact on environment, but also, as we are suggesting, open source software communities. And it's important as a potential contributor that you look in the open source software community to see, is there problems, are people fighting, is there like a big company that is trying to take control, like Patrick said in the examples, to be aware that you can be joining a community that is not going well, that the health is not good, and that it's caused maybe by the companies that are involved. And as I said, sometimes it's super positive, this involvement, but sometimes it is not, and you should be aware of that. And companies themselves, they should be aware that they can create problems in those projects and communities, and that their actions have an impact, positive but maybe negative, and they must state it in their corporate digital responsibility document, that they're going to take care of the open source software communities that they are involved in, and that they're going to be uh, they will have a good stance, and create good in those communities. And for the open source software communities also, once the community is there and that it's strong, to make sure that it can detect in advance those type of problems that can be create that companies' actions can create. So with the root cause analysis that we did, you could also do that. If there is a problem and that you start to think about the cause, maybe you will find that one of the action of one of the company is one of the cause, and then you can address it and maybe go to the foundation to have help to make sure that the relationship does not turn really sour and creates really, really bad health problem for the communities.
So at the end, if I can add something, it's very different for a company to work with OSS communities, not like working with another software development companies with contracts. So we want to see more this entity, this stakeholder in the model, in the software ecosystem. I don't know. Okay. I will do the special thanks. We work, we question, we a lot of participants in studies 1 and 2, like we said, and Linux Foundation's events. They take time for us, and they are good, a really good expert in the open source. So we a lot of thanks to those person, but Linux Foundations to because they open their doors to us for our research. At the SQL project, you can see the the link if you want to see to know more about this project. And in in Quebec, in Canada, we also receive funds by the Fonds de Recherche du Québec to help us in this research. So um, that's it. I don't know if you have questions about that. I know it's more the social, technical, social part of the open source. Like Josiane said, Professor Martin said, we also have a technical background, but it's more about for us the people and the organization of open source who interest us. So, do you have questions?
Okay, so now we would like to open the floor for any questions you might have for Josein and Patrick. So if you have any questions, just raise your hands and we'll bring the microphone to you. Speak in both of them.
Can you hear me?
Yes.
Hey, Jose and Patrick, thanks for a great presentation. It was really eye-opener for us because we are from the industry and we really appreciate such material. So my key question is, are there any organizations who have deep economic interests by using open source projects who may be shipping products for real? And in your course of interviews, you have come across companies which have already framed a very good exemplary corporate digital responsibility policy in place. Are there any examples that already exist that you would have come across while interviewing the experts? Thank you.
For the first part, and maybe I will start, Lucian, about the economic interests. If I understand well the questions, yes, we found a lot of reasons why companies are going to involve in open source softwares, and the economic thing is sometimes a big part of that because they want to save some money. Uh, Other company are going to open source for the creativity or for a lot of other reasons, but the economic part is a big thing. It's a big part of it, and like we said, this thing can really impact the relations because sometimes you know that the communities are not there for sometimes the money, more about the sharing, the values, the project itself. So sometimes the economic part uh, led to some conflicts between the company and the communities. But I think the economic part is it's a big reasons because where company involved in the open source. And for the second questions, didn't remember.
It's about companies that would be good at corporate digital responsibility with open source software communities. A good example. Well, what we found is that there is the Corporate Digital Responsibility Manifesto, if I remember well,
Yeah,
Patrick.
exactly.
It's a group of researchers, companies, open source software experts that decided to create this manifesto saying that it's super important to have those statements, as I said, for companies that are involved in open source software. And even I think this one is even for the lower levels in the involvement gradient. Even if you are just a user, a passive user of open source software as a company, you can have an influence, because if in-house you develop things for your own company that you plug to the open source software and that you're not giving back to the community, you are arming them in a way, because you could, contribute really, and even yourself as a user that starts to contribute, you can have positive a return on that, because the software will become better and better at the basis, the core software. So that's, I guess, the companies that are involved in the manifesto, I would say, are probably really, really good to look at. And Patrick, I don't know if you have it
Yeah,
uh,
but
close, but
I think the thing is, our research questions focused more in the negative situation, so we ask more about that. But I don't know how to say it, but a lot of time, this is not often the intention of the company, and the awakening of this situation has just begun by the company. They now more realize their impact, and they don't have the same interest as the open source community. So maybe we are more we know more negative company than good ones, but I think the good ones, like we said with the corporate digital
corporate social responsibility.
exactly. Thank you, Professor Martin. We are to show which company are doing well in the relation. So we want to highlight this more with our research, I think.
Yeah, this article is it was submitted to a special issue about corporate digital responsibility. Unfortunately, it was rejected because they said that it was not their focus for this special issue, open source software. Sometimes it's hard to publish about open source software still in business journals, but we had some good feedback saying that we need to look more at the intricacies of open source software development compared to in-house or development that is done with a firm, consultants or things like
Yeah.
that, to make sure that we highlight those special things that companies have to look for when they think about corporate digital responsibility in their development. So we will, of course, look more at those who are doing well in this third article. So I would say that the first two projects were looking at the bad or the wrong, doing of companies. So now we are starting to look more at the positive side.
Yeah.
So let's keep in touch. If you want to, at some point, Patrick's thesis will be published on the website of the university. So and maybe we can send it also to the organizers when it's done, and you can see the final results also.
Thanks, Josiane and Patrick. Nice content, very interesting. So, I have two questions. One is related to the first part that you were explaining. Would you see a possibility, maybe if let's say this corporate responsibility is very dear to the community itself, the open community itself, and it wants to protect itself, can it work on a license itself, which apart from software usage also enforces the responsibility part? So you can use this software only when you comply to those standards. So that's one question. Second is with open source, there is, because of a wider, I mean, across geo participation, there is one cultural angle also. And some communities, because some communities, open source communities, may have evolved in their own right sense or whatever, which may not be very adaptable to the other regional cultures in terms of communication, in terms of handling, or in terms of saying no, or likewise. Does your study covers those aspects also? And if you have some interesting data on those lines?
Um,
In the first one,
yeah.
there was
Yeah.
problems related to that. Yeah.
But I think for the license, I haven't seen anything like
Mhm.
that, but I think it's an excellent idea. But we know all of us about how the license, how the IT part in the license but the social part, I didn't see a lot of thing about that. We know about more um, le code pas le code d'honneur, more social code, more social, comment c'est quoi le terme en anglais?
Now he's speaking in French.
Sorry. Conduct, more a code of
Code of
conduct,
conduct.
yeah, something like that, in open source communities, but maybe something like that with the companies. And I think it's a good idea. I didn't see about that, but we're looking forward that for your first question about the license, and to have some restriction about that. For the second question, I don't remember. Josiane, maybe do you remember?
Yeah, well, we haven't seen cultural problems related to companies' involvement, but we have seen that sometimes there are cultural differences that create problem in communication inside the
Yeah,
community and inside the project. For example, I think also when people get bullied in some regions, they don't react as the same as in other regions. And now I think we have to go, eh? But look at the paper. It's in IEEE software. The
Um,
paper about causal root analysis and problems, and you will see that there are some stuff about.
sorry to interrupt you, but please try to wrap it up in 1 minute. Other speakers are waiting. I'm
Yes,
really
thank you
sorry.
so much.
good. Maybe it's the end. We know we have a big day. Thank you very much. Uh,
Thank you all. And what should we do? Should we quit the studio?
Yeah, yeah.
Yes. Thank you so much.
right.
Thank you so much.
Thank you.
It
Bye.
was
Good
great
night.
having you.
Thank you.
Thank you.
Bye.
Thank you.
Am I audible?
Great.
Yeah.
Okay. Sorry, I was a bit confused with the time zones. Okay.
Yeah. No problem. You can start. Okay.
Okay. Is my first slide visible?
Yeah, you are visible. Your
Or
slide.
maybe.
Okay. Yeah, your slide is also visible.
Great. Okay. So I'm Oliver Völkers from Berlin, Germany, and I will talk about how to build a wireless wastewater monitoring system using Zephyr RTOS nodes. In the past, I spoke already about the wastewater monitor, so the individual sensor and the unit that you see here on the right. But now I will talk how to expand it to a complete system. Okay, now how can I advance this slide? Okay, so just to recapitulate, monitoring wastewater tanks is a requirement for the train operation, especially with high-speed and long-distance trains, because the toilets and the bathrooms discharge water into tanks. It cannot be emptied on the track. So these tanks must be emptied in regular intervals, approximately every day or every 2 days. And these pumps are connected via hoses that we will see in a moment. And this disposal process takes about 1 or 3 minutes. And this is a difficult process where something can go wrong. And if something goes wrong, if the pumping process is interrupted, then the train operation is also compromised. That is why it needs to be monitored. Now, the existing system is completely analog. The existing system is to connect the hose to the tank, and there's no digital reporting or anything. And there can be failures. For example, a train can be delayed, or the staff cannot be available on site, or there might be defective pumps or defective valves. And if there's something wrong, then nobody notices it in the moment because it's not recorded and the information is not transmitted. So the information typically gets lost and the defect just continues, or the broken system will continue to be broken in this moment. And that is why we need a digital monitoring system. Now, the system that we have built is the digital unit that you see on the right side. On the central photo, you see the train with a host connection. And the tanks are identified via NFC tags. So with NFC, near field communication, they communicate the number of the train and the number of the tank. And this digital system recognizes the flow of the wastewater, and it automatically detects any faults and reports them immediately. And it connects to the IT from the railway operator. So we can be sure that the information gets to the right place. Now, this adapter, that's why I'm speaking here today, is using a Zephyr real-time operating system. And we used Zephyr because we didn't want to have any new approval required. So we have something that works already, which is electrically safe, which does not need a high voltage power connection. And we also need to secure the data transmission. And also it would be complicated if there would be any switches or buttons. So the operation is completely automatic. Now, why did we use Zephyr specifically? Because we have multitasking of peripherals. We need real-time operation. So that's why we use a real-time operating system. And also it needs to be very energy effective. if that would not be the case, we could use Linux as well, but this is battery operated, so it needs to run for months with a single battery charge. And also, in contrast to proprietary systems, we need a long-term service. So we need to be able, in 2 or 3 years or 5 years or even later, we need to be able to recall and reconstruct a certain status or a certain software level. We need to be, the versions need to be available, and it is necessary that they are not limited with a commercial license. So, for example, if we would use a Microsoft operating system, we would not be able to return to a previous operating system easily after several years and development system. So this also increases safety. Now, the signal evaluation works in a way that it automatically recognizes a flow with a pressure sensor and with a temperature and moisture sensor. And it evaluates the complete process, not just the sensor values, but the sensor values over time. So the difference compared to usual flow meters is that the whole picture, the whole process, which can take several minutes, is processed as a whole, like a picture evaluation, like evaluating a photo and not just a single pixel or not just a certain parameter, not just a single parameter. Okay, now how to expand it to a complete system. What I just described was a single unit, but the advantage only becomes effective if it is expanded to a larger system, because an individual unit will not make much of a difference. And the analogy that we can see here is with heating monitoring, or with in India, I don't know, you probably don't have not so much heating, but more climate and cooling, and but you might need both. And if you have a digital system that evaluates that in modern homes and in modern buildings, this is already standard. So if with a new built house, we can expect to have a digital system that not only monitors the climate, the moisture or the humidity and the temperature, but also transmits these data to a central unit and influences it. And the advantage of such a system is bigger if you have a larger system. So with a large building, the savings will be much higher than with a smaller building. And that's the same with a wastewater monitoring, as we can see here. Sorry, it should be this slide first. So the goal is to have a complete monitoring system where all the sensor nodes are interconnected, where you have the network effect. If more units are added, then you have a bigger picture and you have more information. You have a better overview of the whole system. And the idea is to have an expansion of one location after another, so one maintenance station after the other. And this will be economical, and it will pay for itself because it allows to optimize the disposal planning and saves energy and reduces the number of breakdowns. And the current status that we have right now is that we have a pre-series of 36 modules in continuous operation for over 2 years. And we have tens of thousands of disposals that have been analyzed. And we were able to report thousands of faults immediately. However, because it's only a limited system with only a pre-series on mainly one maintenance station, we only have some kind of well, it's not a complete, it's just like a statistic. We just have a small probe, and we don't have the complete monitoring of the processes. So missing disposals, for example, they go unnoticed. So if a train misses the maintenance station, nobody will notice because we don't have an overview of the whole traffic and the whole disposal at the maintenance station. And full transparency will require a full rollout of the system, and that is what is being planned for the future. So if we have a full rollout, then and if there's a full overview of all disposals, then we can immediately detect and follow up with any problems that there exist, and also we will have a complete monitoring of successful operations as well. So we can ensure the quality, and we can improve the speed and reduce the cost, and that can be done without without working more. So we don't need more effort and more time for this work because we can optimize it. We can find the bottlenecks and fix these bottlenecks. And if there's some broken hardware, we can fix the broken hardware. And that will make work easier for everyone. Okay, so that's from my side. These are my slides. I don't know exactly how the time is right now. So if you have some more time, we can maybe take a few questions, or as you like. So, okay.
Guys, are there any questions? We can bring the microphone to you. Yeah. ये भी, ये भी.
Hey, hi, Oliver. Is it working?
Hi.
Hello. Hi, Oliver. So, just wanted to know, like, this current system what are other applications are there for this kind of system, where it can be used? Maybe.
So this is a complete new system. So I'm not aware of anybody else doing this with wastewater monitoring in the railway industry. In other industries, there are similar applications already. So with, let's say, oil drilling, or with water pumps, or in that kind of industry. But there, because it's not wastewater, it's easier to achieve. I think this is a niche solution, but although it's a niche solution, it's a very large niche because it can be used everywhere where wastewater is pumped, and for vehicles especially. So not only railway, but maybe also camping sites, or with vans, or caravans, or all kinds of vehicles, ships maybe, they could be used properly there.
Thank you so much. The time.
Okay, so thank you, Oliver. And I would like to thank you all for your participation. It has been a pleasure having Oliver with us today. We are grateful for the time and knowledge you have shared with us, and let's give a huge round of applause to him. Thank you, Oliver. Thank you.
Thank you a lot. Thanks a lot for having me. Goodbye.
So, but which one is presenting?
This one is presenting. You
carry on with this one.
I
Okay.
will.
Yeah. Oh,
Wait.
I'll move to the next slide. We'll check on next slide. Okay.
You can directly do it from here. Like you can just slide.
Yes, but it'll work on animation? I don't know.
I am not sure, but you can check it.
Okay. If it is not working, then I have to stop and put it. Yeah. No worries. Yeah. Achha. Hello. I think we're good. Anish, can I get the water? Thanks. I have. But I don't think I need mic. My voice is audible, right? The last one. Can I request like you to just occupy the first one so I can engage you with better? Yeah. I'm not going to ask you any question, so just don't feel hesitant. You can occupy the first chairs and all. Yeah. And you don't need. I'll find. Yeah. I think we wasted a lot more time. Yeah, as I said, right, I'm not going to ask any questions, so feel free to come and sit. Okay, fine. Settle down. Yeah, thanks a lot for attending a session at 6 p.m. It's amazing, right? Like when you're in college, I don't think people ask you to attend the session. At least when I was in college in 15 years back, nobody asked me, right? When you go to corporate, maybe due to the work pressure, you need to attend some meeting, but not at this hour. So first of all, congratulations to you that you could able to change yourself when you're in college. So I hope people are doing good here, right? You don't need to stop, right? Okay. So again, hello everyone. My name is Shubhruto, and thanks for joining this. I know it has been raining outside, and it is late, right? Irrespective of all these challenges and all, I could able to make it. So we traveled from Bangalore. You can understand that how much effort we took. That too on a Saturday on the weekend, long weekend, right? So appreciation on both the side, right? So I decided to give a talk, right, on a topic which is not often discussed compared to its counterpart in the computer science or technology. And I hope in this room, people are mostly from the computer science and technology background. I don't mind if some mechanical, electrical join. It is all same. Like after all, we are engineers, right? So the topic that I'm going to talk about is firmware, right? So and as is the student community, right? So I thought of picking a buzzy word or the jazzy word, I would say, that is the hidden code that powers our world. So throughout my session, I will try to justify or defend my title. Please feel free to come in front and sit, right? It's fine, totally fine. Right. So like why I took this word, right? The hidden world and the powers of our world and all, right? I'll try to justify that. If I'm not, I'm here like today and tomorrow as well. You can try to reach me out if you're not satisfied with my justification, right? So before going to the next session, slides and all, I just want to ask a question. How many of you actually decided to put AI and ML as part of your career in future? When you graduate from college, you want to pursue AI and ML. How many of you decided? 2, 3, good. So ask me the tough question now. How many have decided to pursue embedded in your life, right? Good, 0 answer. This is what I expected, right? So it's 0 versus 3, right? So that is where I come into the picture, right? So let's go to our session. So I try to split the session into the multiple phases. We will first talk about the embedded system, right? So what do you call by embedded system, right? And how it is fitting to our world, right? And second, we'll see why I call the firmware is the unsung hero of the embedded system world. And third, we will see why somebody should pursue their career in firmware. What's the importance of pursuing career in the firmware? What challenges or what remuneration waiting for you? Because when you are in college, it is more important for you to having a very prosperous, shiny future, right? But at least you can take a one step towards that, right? Fourth, so this is the problem, right, guys? So I'm presenting on the Windows PPT, which I don't like. It's not because I work at Google. It has been for me last several years that I never use PPT, right? So maybe some fonts and all, I'm not very happy. I always prefer my Chromebook to present, but I'm just presenting. I could see it already started breaking. So then fourth is very important, to prepare an industry-ready knowledge personality, because we hire, like we Google hire from IIT Kanpur and all throughout the IITs. When I got first invitation from Sanskar, this is the reason I came here, because we hire from IITs. And for me, it is important to pitch the word at the right time, right? Because when I got the resume that, hey, like these people are coming from the IIT Bombay or IIT Kanpur to my team, right? So I know that there might be some people who have hired to me and they have taken the right step in their first year or second year, right? It is easy for me to get a ready-made engineer, because when you go to the big tech companies, we always looking for the ready-made engineers. Fourth, if time permits, we will have a quick demo about the Chromebook, and there are a bunch of Chromebooks, right? So like my team sits there. Can you just raise your hands? So they are all Googlers. So we build the Chrome OS devices. So it's the Chromebooks, right? So these are all open source development platform, right? So we build Chromebook using open source software, firmware, everything. If time permits, because you already wasted 15 minutes. So quick intro about myself again. This is Shubhrata, and this is me actually with a little short hair and like a little bit like a 10 pounds more. Right? Other than that, everything is same. So for me, the in and out, I'm a firmware engineer with a passion of open source in heart. So I have around 15 plus industry experience. Right now, I'm working with Google as a staff software engineer. So I build Chrome OS devices. So in Bangalore, we have a team in Bangalore. So they work in the Chrome book development or Chrome box development, Chrome base development. So our domain expertise is firmware, but overall we build the product together. So like we're the platform team. As I spend my decade over journey in the firmware, so I have 20 plus US patent approved, 2 books. My books will be in the bag. You just open the books and just keep in front here. And I'm the ambassador of the Open Source Firmware Foundation, who talks about who promotes the open source firmware, and the bunch of other the consortium forum that I'm like part of it, whether it's a National Institution of Security and standardization and all. That is enough of me patting myself. So let me start with one quick quiz, right? I know this is full of science student, but can anybody tell me what is the genre of this? I think this is a problem, right? It already says that. I cannot present in this way because all the animation will not working here. Can anybody help me to stop the presentation there? I want to give a try with the Google slide, because then none of my animation will work. I want to stop this. It is actually presenting from the some of the Windows laptop, maybe some PPT or somewhere it is getting presented. Can you just stop it? I want to give a try with the Google Doc. Yes, this is much better. I think as I already revealed that, right? Yeah, this is fine. You can. So as I already revealed the fun, right? So this is a progression of human race, right? So we had the Stone Age and then Bronze Age, then Iron Age, right? So what is the current age that we are living? Anybody, any guess? Good, digital age. So we are living in the digital age. So what does that mean, right? So how things are different in digital age? Can anybody tell me what's two scene is all about? One in 2004 and one in 2024. Can anybody tell? What's the difference? Cool. Very smart people. So this is a picture of the live concert. So 2 decades back when I was in college, that time people go to live concert and all, they go for their self-enjoyment. Now they just don't go for self-enjoyment. Just go to capture the memory, take the memory, put into the social media for the bragging and all, right? That, hey, I went for this live concert and all, right? So how does that mean? That mean is that the number of devices, the users, right? Earlier in a concert, it might be 10,000 people go. Now 10,000 plus another 10,000, your phone. And then people are live, right? We do live and all, right? So for that, we need devices. Let me put one more thoughts on that. So in my understanding or in my belief, after fire, light, electricity, the next biggest invention was internet, right? So it helps to people to connect across the barriers, boundaries and all, right? So today, around 65% of the global population are connected to the internet. It's a huge. Why they could able to connect to the internet? Because of affordable devices, right? So even in the development nation, like India, right? So people are using smartphones. If you follow maybe a year back or a year and a half back when Apple opened their first stores, right? So the Tim Cook said, I hope the Indian people who are tiering from the low economy zone to mid economy zone, now they could able to afford the iPhone. So why Apple is so interested in India? Because the affordability has been increasing. That means the requirement of the device has been increasing, right? So when there are more devices been increasing, you will see there are more, not only your clients are of the device been increasing, you need the devices for your Internet of Things, devices that use that data processing, right? Your backend devices, your edge devices. Now you go to the car, there are edge servers, like there are surveillance camera throughout the city. Those are basically edge servers. When you do a Google search, Facebook and all, right? There are backend servers. So today, in every minute, there are 5.7 millions of clicks that go to the Google search. Again, so as I said, right, it is not only your phone, smartphones or laptop increasing, it's a router, hub, switches, edge, client, all this kind of form of the devices are getting increased. So one more quiz, right? So how many of you uses more than one devices at this moment? Just raise the hand. Okay. How many people are using more than 2 devices at this moment? Perfect. How many people are using more than 3 devices at the moment? Cool. So you actually gone with the data point. So at this moment, people are using minimum 3 devices, right? So me, my laptop, my smartphones, my smartwatch, I'm thinking about buying a smart ring, right? So situation is more and more complex when you think about a progressive nation, like a North America maybe. People are connected to the 14 devices at home. For me, living in Bangalore, situation is not that bad. I have more than 14 devices at home, right? So like the overall, like this point tells you that people are getting used to the new uses, right? How many people thoughts about wearables? Now wearing smartwatch is a trend. 43% of the US, the average consumer of the computer started using smartphone. So now we talk about the devices, tons of devices, right? So let me put everything in the perspective of a generation growth. This is picture about last 5 decades of a growth of embedded system. 1970s, the device was very simple, used for a specific use case. Compared to 2020, people are talking about self-driving car, augmented reality, right? Virtual reality. The use case we couldn't even thought when I was in college, right? Some of you are in school, you could have thought of that kind of use case coming, right? So it is giving a rapid growth, right? So, okay, I agree with you, Subrata. You're talking about rapid growth, but how come the firmware is related here? Are not you supposed to talk about firmware, but you talk about devices? I think everybody agrees there are devices coming. So how firmware fit into the devices? And again, I'm using some buzzword. There's unsung hero for the embedded devices, right? So let's understand why I call firmware is unsung hero on the embedded devices. Before that, try to categorize the device, right? So there are primarily 3 categories that we talked about. One is the client devices, which basically create the data, right? Your laptops, your phones, which actually create the data. Then you have the IoT, which basically consume the data, your smartwatch, your robots and all, right? There you don't create content. And then backend, you process the data. There are micro servers, mini servers, edge servers, right? So these are the devices that consume the data. Sorry, these are process the data. So primarily 3 set of devices, right? So as we have engineers in the room, so when we see the devices, we just don't see the devices color. It's a red colored device, yellow colored device, white colored device, right? We are engineers. We understand the stack, right? So take a look into the stack of the device, right? So we have the only one tangible item in this whole system, that's the hardware. That's actually the source of truth. We talks about the real material, right? So all the peripherals, component, right? CPU, memories, all these things we talk about, this is here, right? And then on top, you have operating system, which is maybe the high-level software that consists of drivers, applications, managers, and etc. etc. Is fine. But again, Subrata, you're missing the point. We're supposed to talk about firmware. Where is firmware? Firmware is here in front of you, as you're all missing it. Firmware is here, right? A sandwich between your hardware and your operating system is called firmware. When I was in college, there is a 3-number question used to come. What is the firmware? And there are only 3 lines required to write that. You write it, you get 3 out of 3. After that, no definition of the firmware, no use case of the firmware and all, right? So here is the definition of the firmware that was missing in my engineering college, right? So firmware is an essential piece of the code that is responsible for performing our essential hardware initialization to hand over the control to the operating system, right? So the devices that everybody of you are using, right? One device is two devices, more than three devices, right? Any device that you can think, you close your eyes, think about any device, right? It all runs firmware. Firmware is the entity that brings the device into life so that it can be operational. And then people can develop their app. It can provide the service. We can all talk about Google search, right? The effective use case of the AI, Gemini, ChatGPT and all, right? Everything is running on hardware, right? But to make the hardware live, you need firmware. So why firmware is important? For two reasons. One, for this bottom layer. So it's a firmware is provide an abstraction to the upper layer, this operating system, about the hardware. I don't need to know what is there in my hardware. I should be able to get the services done. So firmware provides the service to the upper layer. Second, it also try to abstract the operating system also from the hardware. So you can think about this way. I can build one hardware, so that hardware can boot to the n number of operating system, right? So I can build a laptop. That laptop can boot Windows, Chrome, Android, Mac, everything. Similarly, I can build a operating system. There's a Chromebook. I can build to the n number of hardware as well. That is where the firmware is important. It's like a 1:n and the n:1, that kind of thing, right? So now let me go back to my title, which I talked maybe around precisely 7-8 minutes before, that why I choose these two words, hidden codes. What is hidden? So firmware is a piece of code that was hidden underneath of your all modern operating system. Whichever operating system we talk about is a hidden code. We never talked about it. We never know it. How many of you might have known about firmware, right? There is something that is running, right? And none of you actually decided to pursue your career. So I believe that is not very interesting. And then why I call it the power of our world? Because it used to bring the hardware into the life, right? So once we talk, like now, you might have agreed with me, there is a firmware that brings hardware into the life and all, right? That's totally fine. But what are the different firmware you are talking about? Is there a one firmware, two firmware? Think about my laptop. This is a Chromebook, right? So how many firmware that we run? So before that, let's understand what for we need firmware. As I said, right? For firmware, you need a hardware. The hardware is a source of truth. So here, think about a silicon system on chip that basically connects to the tons of components. Could be CPU, could be memory, static DRAM, dynamic memory peripherals, input, output, keyboard, joystick, stylus, mouse, whatever you can think, display, HDMI, Type-C, dock, whatever, connectivity, WLAN, anything, right? For every component that you can think about, there are firmware running in that code. Why it is running? To communicate with the silicon. So silicon also can communicate with the component, right? There's a both sides. So all the components are running firmware and silicon is also running firmware because they want to talk to the same topology. Once we understand there are tons of firmware, right? How do we divide it? We primarily divide it firmware into the three parts. There are tons of people who are in the IT industry, software industries, right? Maybe the grad student, like maybe in the little bit of the postgraduate side, or maybe the PhD candidates and all, right? They not able to differentiate when they press power button and when system boots to the operating system. What magic happens there? How many firmware was there? Then we know that it is our fundamental right as a computer user. When I press power button, system should boot, right? Why system is not booting? Because any of the firmware could behave abnormally. So let's understand what those firmware could be. Primarily, there could be three set of firmware. System firmware, the firmware that is run on the host CPU, called system firmware. Right? So example, how many of you using the Windows laptop? I believe everybody is using Windows laptop. Fine. I think others are just restricting themselves, just not to raise hand, right? Or maybe how many of you are using MacBook? Okay, it's the same. Rest might be Linux, right? So whatever is that, whether you are using Mac, Windows, or Linux, you are actually running UEFI, Unified Extensible Firmware Interface. That's the firmware that you are running in the backend. When you are using Chromebook, that's a Google product. We are running Codebook. That's open source firmware, right? So move the gear to the next one, device firmware. So again, as I mentioned, in numbers of peripheral, all the peripheral that you can think about, it could be a USB-C, dock, it could be a SSD, anything, right? That runs a firmware. It's called the device firmware, right? And the last one is the manageability. It's basically to manage your device remotely. We call it the two term of things. One is the in-band management, and the out-band management. In-band management is what? Basically, for an example, if you have in college, you might have an IT administrator that basically push your update to your machine. If your machine is not working, they often try to ask you, try to log in your machine and try to do some magic to fix this thing. This is the in-band management. What is out-band management? We have the servers, the data centers and all, right? underneath of the Pacific Ocean. And when you do a Google search or Facebook and all, most of the servers are underneath the Pacific Ocean. So like when something goes bad, people should take submarine and go there to fix the problem. No, right? So they use some back-end channel that is called outband management to manage those devices. For that, we have some firmware called baseboard management controller, like a BMC. So you have learned a 3 major pillar of a firmware, right? So how it is important for you to pursue a career in the firmware, right? What you will get if you start pursuing the career. And as I said, right, for student, job is the first important thing, right? Even then the grade. How much of people are worried about the grade, right? People are worrying about, can I get a good, decent job if I learn something, right? So here is a perspective that I thought of putting in terms of the companies, right? So I put the 3 like pillars saying that system firmware, device firmware, manageability firmware, and the tons of companies, those who offer job in that. The green color is the one where we are working, right? So this is my team. So I don't want to go through each and every company, but you can understand, if you pursue your career in firmware, there are ample companies, right, to offer you the job, provided that you understand firmware. So let me put one more perspective. You could have think about, okay, so how many people actually in this world, in this IT world or computer world, actually work in the firmware? So let me put a global perspective towards that, right? So this is the overall the workforce of a typical our computing environment, right? So I create a reverse pyramid. Most of the people that we discuss, those who develop the apps, web, and all, right, they are here. They're the mass, right? You slowly started going down. You are becoming a critical resource. You come to the BSP, driver development, you are critical. You come to the operating system development, you are really critical. You come to the firmware, you are rare. You come to the hardware, you are considering very rare, because those are rare species who works in the hardware, who understand the hardware things, right? So summary is that firmware engineers are still in demand, right? But there are not ample firmware engineers available. Why so? Primarily 3 reasons. First, most firmware engineers should have a very good low-level language practice. And in the current era, when there is a high-level language, there is the influence of AI and ML, how many are really motivated of learning assembly? How many of you actually practice your assembly language? It could be any architecture in day-to-day practice. Maybe the second-year students. Do you practice assembly language?
I don't think as a part of course.
Good answer, right? So this is where today we are. This is not part of the course. So I graduated from government college in West Bengal. So I went to my college 2 years back and I asked that, like, what's the syllabus going on right now? They say, we remove microprocessor and microcontroller from syllabus. I said, why so? Because no company offers job. I said, then what we are doing now, right? My team offered job and I'm searching badly. To hire 2%, I conducted 84 rounds of interview, right? Because I don't find the right candidate. It is not the Google interview stuff. It is just that I don't find the right candidate, right? Okay, moving to the next thing. I'm not blaming only you. I'm also blaming many people. Firmware knowledge is very rare and is not readily available. So it's not your problem. Last, a fact, only 5% workforce, even in US, right, just only works in the firmware or the low level of driver. But there is a fun part. If you learn on firmware, where you can contribute both in the upstream layer and downstream layer. That means if you learn firmware, you can work in the operating system, BSP, driver development and all, because they're all talks about hardware. They're all somewhere provide a hardware initialization. Even you can contribute to the hardware, not maybe as a hardware rework, but you can give your right feedback and all, because this is what we do. When you build Chromebooks, we actually work in this to this layer. We never work this layer. We always work from this layer. Right? So as I mentioned, right, the firmware is not known because there are like many people to blame. So first, let's blame somebody, right? So how many of you seen this screen anytime in your life? 1, 2, 3, 4. Okay, good. So was there a very great day, like a very shiny morning, and you thought, I got very bored. Let me do something else ready today. I'll go and see this screen. What was the day? Maybe the lady you. Okay, your system was not working or something? Yeah. So this is the reason, right? Why firmware is not known, because we only reach to the firmware when things are really screwed up, right? A bad day is when we see firmware. Who want to be in this domain where you see the things in the bad day, right? Everybody into the domain where people always see things, right? So that's the reason I call firmware is a invisible man. So this is actually me who has face, but here it doesn't have face, right? As I'm a ambassador of the open source firmware, right? So why and I put a word in the blue. I'll try to define that word as well. We always believe, like whoever in the firmware domain for longer time, we always believe the firmware has to be a value neutral or a value zero. So let me explain, right? So value neutral means it's neither plus nor minus, right? So why not minus or why not negative? Negative firmware means there is no firmware. It's a paradise, right? You just come and try to touch your hardware from any layer. How does that matter? Your attacker will love that kind of platform. They can attack things straight away from their up application layer to your hardware. It's basically like they're putting hand in your pocket and taking money from your pocket. They're very happy, right? Second, positive. A firmware is positive means what that lady actually says, because every time you boot, you see a firmware. That is not a very good thing, right? I don't want to see firmware every time. So again, a successful firmware is the firmware has to be value neutral, neither positive nor negative. I don't want to use firmware, I don't want to see firmware, but it is there. It is there to do the required thing. So it's an art to keep firmware a value neutral or zero. For that only people will pay you, because you want to maintain something as a value zero level, right? And again, for all my friends, I think three friends raise hand for the AI NML. For AI NML, you really need a hardware to run your machine algorithms, right? Whether you're running on servers or you're running on the local machines, to bring those hardware into the life, you need a firmware. So here your life circles back. You cannot escape from the firmware. Either you understand or you ask somebody to make that understand. So your AI ML logic works. How many of you know what this picture is? Good. What's so special about this picture? Who can actually pass through this? Okay. So basically, who want to go to the Hogwarts? So they are the sacred people, the special people who can go there. This is how the firmware is positioned today, right? Firmware knowledge is often overlooked, right? So hence this knowledge exists today, but it is actually maintained or managed by a certain set of people. I call those are like sacred engineers, right? Why so? And this is the time you can only blame your academics. The right word that you said, that it is not part of my syllabus. In our college, they taught us operating system, they taught us the microprocessor, they never taught something middle to that, right? So who can teach this us? And then, right, why a college should teach something that IEEE itself is not very taking interest? So this is IEEE definition about firmware. IEEE says this is a tiny block of the block that combines hardware driver, computer instructions, data, reside in a read-only software devices. The academics has lot many works, right? They have to teach you something that's meaningful, not tiny, not read-only, right? So this is where the things are actually getting messed up. Nobody tells you the importance of it. If the syllabus would have tell you that, okay, this is essential, this is specialized, right? So no academics would have avoided that, right? And so let me put you a different thoughts here. This is our overall the system stack, right? So whoever works on the application, they works here. Whoever works on the kernel, they works here. In your college syllabus and all, when you read your operating system chapter, you actually will learn that operating system is more secure, because the kernel layer is more secure because it's a ring zero layer. Like no access would have allowed, like no access from here to here would have allowed here, right? So firmware is below this. If this is secure, then this is super secure. They only teach you this, they never teach you this. Even the NIST, the National Institution of Standardization and Technology, they enforce every organization to make sure you are getting updated. That's the reason all the devices that you're using, whether it's Mac, Windows, Chrome, everybody, Linux, they are bound to provide you update for next 7-8 years, because a vulnerable firmware could be dangerous to the entire platform, the entire environment, right? It could be a paradise for the attackers. So why the operating system knowledge is not closed source? Why they taught operating system in college but not firmware? Because of 3 people. Can you recognize these 3 people? Starting from here, Dennis Ritchie. 3rd-year people would have known this person. Distributive operating system, Andrew Tannenbaum. Don't you, like, they don't teach nowadays? Like, I'm that old? Maybe. Okay, so thanks to these people, right? So they actually change the paradigm of the learning. right? Nobody learn operating system because Microsoft is teaching you. Microsoft only will teach their engineers, right? Whom they will hire. But the open source actually help you to learn about operating system, right? So no magic happened in the firmware world like the magic happened because of these three great people. They took an effort. And if you don't know about any of them, just go to YouTube and watch some video that this guy actually put. I'm a big fan of this guy. So again, why such magic didn't happen for the firmware? Because since the origin of the firmware, right, the firmware is always very closely tied up with the hardware. And the company who prepared the hardware, they always prepare firmware. That's the reason this knowledge, like when things get decoupled, right, people try to innovate. If things are very tightly coupled, nobody try to innovate. They say, "Ha, theek hai, chal raha hai. Ye bhi chal raha hai. It is like also going on, right?" Second is that your hardware is not free. Then why the firmware should be free, right? And the last and the most important thing is the mindset. Open source is a mindset. If you are not open source in mind, you will not able to open source, right? And most of the hardware vendor, hardware company, they think there is some magic that happens, and they know that this magic should not go out of their employees and all, right? So fortunately and unfortunately, I started to a company who perform a cult on the firmware. That is how I learn firmware, right? But I don't like in that way. I want that cult, that knowledge, that the process, right? That has to be open up, because thanks to these people, we learn things, right? So this is our opportunity to give that to our next generation, right? So good news is that open source firmware is a reality, right? I think since morning I heard about more talks about Zephyr. I don't know how many of you know what's the full form of Zephyr, or what the Zephyr actually all about, right? That's one of the open source operating system, right? We use that as a part of the firmware also, right? So there could be a tons of open source firmware that we use, build our product, and Chromebook also use Zephyr. So enough of blaming the other companies. So now let's blame you also, like guys as well. So like when we talk about firmware, right, we always looking forward to smart engineers who can actually optimize the program, perform the classy programs and all, right? So this is just a simple example. So determine the size gap between a code cache and data cache. I think you might have read in your computer architecture, there is a code cache and data cache, right? So code cache is some bit definition, data cache is some bit definition, right? So you don't have to go to the algo and all, right? So a normal or good programming practice will just use this algo and write the code in assembly, right, for creating this. But an efficient programmer will use that algo, which eventually will take a different set of T state. And as I'm running short of the time, I'm just summarizing it, right? So between a good programming and efficient programming, you will find there's a difference of around 8 T state. So this is the difference for what people will hire you when you pursue your career in firmware. For us, space and time, those are very critical. Your system has to be really fast, and system has to reduce the cost, right? When you pay attention to those, that is when you become a firmware engineer. What it takes to become a industry-ready firmware engineer. So this is again a bunch of steps that I prepare, which I believe based on my experience of 15 years, which maybe this is what I would have done. You have know the importance of firmware in my college days, right? So most of you study these programming languages. You also study the data structure. And I believe in the college syllabus, they still teach you these basics of computer architecture. Then there are practical knowledge required. When you understand the signals, you use like real some hardware toolings and all to scope that out. And this is how the advancement comes to the picture. You also need to understand the CPU architecture, the leading CPU architecture, x86, ARM, RISC-V, and I divide into two categories: good to have and kind of a desire to have, right? And then microcontrollers, more advanced bus architecture, because this is how the components and the SoC communicates between each other. Then compilers is very important. You know the source code, but when you compile, how it generates the binary. Do I understand compiler? I still believe in the college syllabus, they still talk about automata. They might have give some sessions about GCC. And this is a specific domain knowledge that you guys cannot get until unless somebody comes from the industry and help you out. That's the reason I came here, right? Domain knowledge is very important because this is how you apply your knowledge that you gain, right? And then you understand the technology. I think I attended some session, people are talking about Zephyr, people are talking about ARM, TFA and all, right? These are the buzzword, but ultimately you need to understand what is the architecture all about. Like at your age, when you are learning something, try to use Google or try to find the material in GitHub and try to study that. And finally, debugging. Because when you in college, you mostly spend your time on development. But when you go to industry, you spend more time on your debugging, right? Try to pick something which help you to debug the code and all, right? So when you combine all these things, you almost get the 80-90% of gist that a typical software engineer going to the industry takes 5 years to get, right? So again, I write these 2 books to share all this experience that I learned from my career, right? Here I'm not here to promote my books. I believe you guys have some campus program and all where you can go to the either APRES website or the Springler Nature website. You can download the book free copy. You can just read it if you're interested, right? But what I'm here to tell you how you should start the journey. Always the journey start with understanding the origin of the firmware. How's the category of the firmware, which I just talked about. There are device firmware, system firmware, manageability firmware. Just find which firmware that interests you most. Then next big thing is that try to understand hardware. I met somebody who said, I like chips. Maybe that person, right? Yeah. So if you love hardware, you must be loving firmware, because that is actually right. If the firmware is not there, then hardware will be kind of a like the body is like without its soul, right? So firmware is the one who try to put a soul for the hardware, right? To try to understand all those bus architecture, then your instruction architecture, CPU architecture, and all, right? Then for everything there is a complex design, but even the design is complex, there could be a minimum way of designing it. Try to understand what it takes to design a very minimum firmware that meets your purpose. I believe at this era you have tons of evaluation board. There are Beagle boards. People are giving session on the Beagle board. When I was in my college, I was doing the Beagle board project. I took EDK2. If you don't know what is EDK2, that's a open source UEFI flavor. We took EDK2 and we tried to boot a Beagle board, right? So that like there are tons of platform available, but for that you really need to know which technology that will use. And this is where it comes to the picture. If you know the technology, right? If you know what are the different firmware technology available, UEFI, code boot, slim boot, or boot, U boot, there may be tons, right? Try to understand those basic architecture so you know for which platform you will be what. If I give you a Chromebook, which firmware you need? If I give you Arduino, if I give you a bigger board, which firmware you need? What I want to boot? Based on that, you design your firmware. What if some of you get placed into the silicon companies, those who are not feeling very comfortable with open source? You really need to understand the closed source as well, how the closed source firmware works, how the silicon firmware works, right? So there is also a certain specification available in the market for AMD, for NVIDIA, for Intel, AMD, and all, right? So just go and try to learn that. There are different types of firmware that is required for your hardware initialization. There is a different kind of firmware that is required to boot to the operating system. So we call it as a payload. So payload could be tightly coupled with something. It could be loosely coupled with something, right? Try to understand the difference. What is the leading payload? For example, on Chromebook, we use some open source payload called depth charge. It is very loosely coupled. That is designed for the Chromebook, but may not be useful to boot a Linux or maybe booting Android, or maybe booting Windows. For booting Windows, we use different payload. So this concept has to be clear in your mind. What is my target platform? I want to boot a Linux, I will use a different payload, right? I have to boot a Windows, I will use different payload. So once you understand your system firmware and all, this is a time to pay attention to the non-system firmware. That is I said, right? Manageability firmware, embedded control firmware. This is where the Zephyr comes to the picture, right? So Zephyr is the embedded OS that we use to build a firmware for the embedded controller, right? And the generation is moving towards when in like I was in college, I learned assembly, I learned C, but now I feel like learning the Rust is the next thing, learning the Go is the next thing, right? So be prepare yourself to match with the trend. And you guys are very young. I think this is your time. You can learn any programming language. When you learn software programming, everything is fine, but ultimately you need some tools, right? You need to run some bunch of tools to even generate a binary out of the source code. So have understanding of the compiler, as I said, right? The build tools, the configuration tools, right? And then how to update the firmware, because again, there will be a read-only memory or a temporary memory that you need to update it, right? For that, you need a bunch of tools, and that tools will be talked tomorrow in our workshop. That how do you update the firmware, how do you build the firmware and all. And when you know that how to build a firmware and all, you typically start collaborating. You come to open source, you start collaborating. There are a bunch of community projects where you can collaborate, but collaborate means you need to understand how this SCM works, right? So any the job opening that I see in Google, in anywhere nowadays, they mention that Git, Gerrit basics are common. That was not the case when I was freshers, right? Nobody expected me to learn Git and Gerrit. Now this is a trend, right? People expect that you should know how to collaborate, because people are now in the post-COVID era, people are mostly working remotely. So the collaboration is important, right? How do you write a proper community messages and all. Somebody was talking in the morning session about the Linux plumber conference or pushing a patch to the Linux community. If you push a patch with this kind of definitions, right? Oh, I write this code and everything is working with this code, it is done. You basically get blacklisted. Nobody's going to review your code, right? So when you are doing things first, and as you guys in college, I want to tell you, put a very important muscle memory to you. When I write a commit message, try to write a very nice commit message, because this comes to your muscle memory. You will never do all this kind of mistake. Oh, I'm writing this code because things are working fine. Please don't delete my code because it will break your platform. Like, not this kind of thing. One of the professor from University of Washington mostly, who read my book, a particular chapter about debugging, and he told me, Subrat, if I would have known the importance of debugging when I was in college, I would have spent more time. Because until unless you go to industry, nobody will have talked about a debugging. How many of you actually pick a project about debugging an open source project in your final year? I dare, like anybody would have picked that. Okay, sir, I want to debug open source code. Let me put that thing, right? Right? This is where we do most of the things, right? We take others' code because it's a collaborative work, right? This is what is tough to work in the open source project, because you are cleaning somebody's mess. So debugging is very important. Try to be updated to the latest trend. You are working with Intel processor, AMD processor, ARM processor. Everybody use their own debugging tricks. Every tricks are different, right? Hardware interface are different. Try to understand those techniques. Secure. Security is very important for your product, right? So we have seen like some recent security incidents and all. Like maybe if you remember 3 years back, there is a Spectrum and Meltdown issue. There is a Tucktau issue. There's a Rowhammer. Just Google all these things. I just don't want to go to each and everything. The bottom line is that attackers are finding very easy nowadays to attack the firmware, right? So we want to build something that is secure. And how come the security, right? Like firmware need to be very secure with some security techniques, security practice. This is another domain. Like there are field called security researchers. So try to spend some time here as well. And when you finally gain all this knowledge, most importantly, do some hands-on. And when you're in college, pick some hands-on project, right? I just put few projects which I felt very interesting, right? And any of you need my help to help you in your project, right? I cannot give 100% of my commitment, right? But I can always help you with my inputs and all, right? Definitely you'll find some mentors, your final year student, your college professors and all, right? Who can motivate you of developing this. And again, if you need some industry folks, yeah, I'm always here. As I already mentioned, think about beyond just C and assembly or C++. Rust is the next big thing. I started learning Rust. Many people are working in the firmware just started learning Rust, where it's a memory safe language. And Golang is another thing, right? So again, just giving callback, right? I'm not saying that if you read my book, you will be able to understand all these things. What I'm saying is that if you go through the step that I mentioned, right, at least you could be able to complete 70% of the spectrum that I shown maybe a couple of slides before, right? So it is important that you spend time there and you gain all this knowledge. So assume you have done all these things, then what you should do? You should come and collaborate in the open source project. There are tons of open source projects. Codeboot, that is also part of GSOC. And when you're a student, I think GSOC is the most important thing for you to get placed into some big tech company, school company. So my team support this one. So if you are registered in Codeboot for GSOC, you may find me as your mentor. You can find my team as your mentor. So we participated in 2022. It was too overwhelming and we are so busy. So we dropped from 2023, but we may join next year as well, right? Apart from that, there is Zephyr. We do open source firmware conference, which is happening this September. There are UFI forum as well. There are tons of forum for you to collaborate, right? I don't think I have a time, but just that we have an immediate next session that is talking about a Chromebook. As I said, what you will do if you learn all these things, you can build such classy product. So you just pay attention to this line, right? So all Google product, this is a Chromebook product, is developed using an open source project. So we use software, firmware, everything open source. All the device that you have here, you can go to the GitHub, you can find all the project link. You can download all the project, you can build yourself, you can build your own firmware that runs on this Chromebook. Tomorrow we have a session, we're going to talk about how do you build products for the Chromebooks, right? This is how I want people should be collaborating, right? And when I'm coming on, my team is coming to hiring in IIT Kanpur, I know who are the people need to hire, right? So again, I just want to end my session saying that next session will be talking about the Chrome firmware 101. We'll be going a little deep about the firmware. And tomorrow we have one more session about building the Chromebook with the Chrome firmware and all. So with that, thank you. And we have time for question and answer. Go ahead, please. Code boot? Yes, yes, yes. Good, I can give that answer, right? So typically, if you see the U-boot is mostly used for the product, which is very bare metal, like the evaluation board, test boards, right, and all, right? And here we want to build a product which is like a enterprise. What is it? A spec. U-boot does not really follow a standard specification. Wherever the code boot follow a standard specification, and it is also how industry adopts it. When we take this firmware and we ask a SoC vendor that which one you are comfortable to collaborate, right? You will hear a different answer to the different SoC vendor. If I go to maybe ARM, they say U-boot. If I go to x86 vendor, they say core boot, and all, right? So for us, when we work on the laptop, mostly we work on the x86, which is the Intel and AMD because it's powerful. But when you come to the phone, you basically work in U-boot, right? And also there are a few security features which we integrated with code boot. For example, verified boot. Like our team will talk about that. Those are easily integrated with code boot. I'm not saying it cannot be integrated, right? So very first Chromebook, maybe 12 years before, first Chromebook launch with U-boot. But then we estimate, we do the analysis of security model and all, and we figure it out that U-boot is not that secure compared to code boot. So we switch to code boot. Mm-hmm. Correct. Yeah, at least the laptop are still 80% market with Intel. So. Correct. You mean with the Snapdragon 8X or something? Correct. 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 It's ARM core. We are continuing code boot because like I think you can wait for our next session, like how the Chromebook is secure or how we are building security and all. So from our side, we are still very committed to the code boot because one, it's open source, and open source is the theme of the Google product. Like we believe all our first party device should run a first party firmware. So when we build Chromebook, we should know the firmware that we are running. We don't rely on others, right? You know what's happened when you rely on others, like Counter Strike happened in that case, right? When you give things to the others, and I ask them to integrate with your OS. So we believe on our stuff. It does not mean code boot is owned by Google, but Google is the primary contributor to the code boot. Any more question? So I could see two hands. Yeah, I think he raised first. Okay, go ahead. Correct. And second one is that firmware basically is designed for a particular hardware. Correct. So the hardware, suppose your Snapdragon is 888, so it's more efficient hardware than the prior one. Correct. But so i86 will run on a different firmware than the 8881. Correct. So it's a kind of incremental. So basically, if I understand your question, so this is what we do. Correct. So basically, what we do, we always latch on the n-1. So we call it as a n-1 SoC and n SoC. For example, all the SoCs are basically backward compatible. Yeah, there could be something new coming, very new coming. That is where our value comes to the picture. And if you follow that in your case study, I try to put one case study saying that design a firmware for a very new SoC architecture. How many of you thought maybe collaborating with IIT Madras and build a core boot using Shakti? Shakti is very popular. Like maybe during COVID time, I went to a workshop in Stanford, and we are talking about RISC-V open source silicon, and Shakti's name came to the picture, and I was proposing let's use Shakti to build a firmware around that, and we use this time not core boot, we use OR boot. That's a Rust-based firmware, right? So again, when you do something very scratch, we do something scratch, but mostly we do the increment. That means there is an SoC and new silicon feature comes in. We try to only write those blocks. So code structure, and that is where maybe the U-boot is not that great compared to code boot. Code boot structure is very organized, right? Where adding things, basically you have to think about like a model, like a base model, where all the base common piece of the SoCs are inherited, and on top of this, you just add a new layer, what this new SoCs bring, right? So this is how basically we design. I hope you understand the overall of it. If not, then you can catch me and try to talk about that, right? And you have a question? Yes, so basically it depends on where is your attack vector. So mostly the jailbreak is where you basically turning off the security keys, right? So when you purchase a product, you basically sign with the security key. Like for example, when you purchase a Google Chromebook, and we actually sign with the Google key, like Google security key. And we have a mode, I think Dinesh will talk about that. We call it the developer mode. The moment you go to the developer mode, you can basically build a code boot with your own signing keys. right? So that means you can actually boot a non-Google OS as well, like non-Google signed OS. So that is basically kind of jailbreak. So when you jailbreak it, you're basically telling, hey, I can boot any signed image. I don't need a company signed image only. And that is basically how happens during your booting time itself. So you stitch a image, firmware image, and update the firmware image. So you can take this signing and all this thing out of the picture or out of the equation.
But these are usually done with like power fluctuations and stuff. Right?
Yes. Why? Because your hardware has to understand that you're trying to do jailbreak. These also happen like this on Chromebook also. There is a special key sequence required. You are telling your other processors, the other auxiliary processor and all, hey, I'm trying to reset it. I think Dinesh will explain that when he's in his session, that how to go to the developer mode. You're totally right. And you actually understand that there is a fluctuation happening. You basically tell the signals that I am resetting my controller. So don't bring security into the picture now.
But is it possible to secure against that?
No. So that is you are knowingly doing. You know that you are actually doing that, right? So some device provide that jailbreaking option. If you want to secure, you can halt your system. You can tell I don't allow, I don't support this model, right? I can halt. But what I'm telling you is that some device organically support, and Chromebook support that, because we want you purchase a Chromebook and use for your developer purpose plus your work purpose as well. Same Chromebook, I can use this Chromebook to debug that Chromebook. I can use that Chromebook to debug this Chromebook, right? So it can become a debug platform or my development platform. But what you're saying is that, can I block it? Yes, you can always block it. You can say it is not supported.
Is the firmware software something can be controlled by a net? Means somebody from Google will control the.
Yes, you mean the update?
Yes, sir. Like the OS can be
Updated.
Yeah, Android can
Yes. We do. Like we basically, I think how many of you know actually every month on your Chrome browser, you see click this to update. That is where the Chrome OS get updated or the browser get updated. When you're talking on the Chromebook with the same package, we also update the firmware. So we send that. So not every month, maybe it depends on how many bug fixes and we are doing. So I know how many bugs we are fixing for the next platform or the platform that is yet to release, right? Or maybe this platform that I'm carrying, right? So yeah, we update that. And maybe that is where maybe tomorrow we'll talk about that. How do you update the firmware? Okay, cool. I think we are getting late. We need to move to the next session. Okay. Thank you so much. And I need to present my next session. I need to start. Just give me a second.
Guys, Ayush Chopra session at 14 is going to start. Whoever wishes can join. And Ayush Chopra session on.
नहीं मैं मुझे जस्ट ये डॉक्यूमेंट इसके साथ शेयर करना है.
Guys, we have some stats from Google side. I think we can distribute it. Please.
Can you ask her to come? This internet is not working. Yeah, if she can provide me this. Can you allow me to connect to this internet? I don't know. Like this one is not connecting. Maybe it lasts for the sign in. Yeah. We are going to share this deck. No, like I'm tying on my phone. This room it is not taking. Yeah, I think you just connect so I can give the access to him. Yeah, no, I'll just give to access to her laptop so she can. Yeah, I think it's working, right? Yep. Thank you. This is fine. Yeah, I'll just meet for a minute maybe. Let's share. Yeah, so I'm just sending to her. Maybe can you just try to open from here? Yeah, this. No. I think you can go to the email because I just share and you can start presenting from here maybe.
Okay, this is one of our.
Yes, and this is Gmail. This is maybe her. There may be some Gmail account already. Yeah, it's here.
This one?
Yes. Just maybe just put slideshow mode. That should be fine. Okay, cool. Thank you. Sure. Achha. Rishika is motivated, so staying in the lane. Rishika को पता होना चाहिए कौन सी स्लाइड उसके लिए बनाया था. She knew? You know, right? हाँ. क्या कौन सा इशू? नहीं हमने स्लाइड चेंज किया ना. So I actually share her the one slide, and I'm sharing the next slide as well. Yes, like I was designing जब सब लोग चले गए, उसके बाद लोग आके बैठ गए. हाँ, correct. I thought कि चलो ये तो सही में ड्रीम वाला ही हो रहा है. We could have loved to give that swag. I don't know. Have you used Chromebook anytime? Then you can start just use that. Yeah, I could have just loved to give this as a swag.
And they are all with custom firmware.
This is codebook. This is all open source firmware. This is all running open source firmware. So this is all Make in India Chromebooks. So all these Chromebooks are available in India.
So you get them with open source firmware.
No, we build it. So this is the product that we built. So this product that my team that built.
Great.
Yeah. So I thought, I don't know, like how many people in college they use Chromebooks. I thought of bringing some Chromebooks.
Great.
And this is maybe our just last year. So this is this launch maybe this year or sometime. This all launch. So this is this is like maybe less than $200. Okay, thank you so much. Thank you for staying late and listening.
But one is from us. There's also some from and there's 3 from the competition.
Yes, so you see that this is a premium one.
Yes. We use it daily for our purpose.
Yeah, so we actually this. So this is actually our enterprise laptop.
How does it work?
No. So you can understand that this is a $200. This is $800.
That only works once here.
This Chrome OS.
Hello?
So if you follow the Intel processor, so this is Intel Gen 12. This is Gen 12, Gen 12, Gen 12. And yes, which is last year. Like this year, the product that we launched, it is not yet available in India. Yeah, because typically things come a little late in India, right? So we just launch maybe sometime back. It might be in the Amazon.com or something.
This OS is not only few laptops.
In India?
Yeah, this OS, Chrome OS.
No.
Chromebooks, Chromebooks.
These are the
Just scan this code maybe. Just scan this code. Right, and you can scroll down. You can there's a tons of the Make in India devices. It will take you to the retailer, like who are all selling, right? And if you're,
Windows will be changed to Chrome.
no, Windows is different computer, and this is different computer.
OS might be changed.
So what you're talking about is a Chromebook Flex. That's a flexible OS. Yeah, thank you.
Are we still broadcasting or not?
I think yes.
Yes. Only to know because here someone already came and closed these boxes.
Oh no, it is here. It is here. The box is here. Yeah, I think we can get started. Maybe it's fine. Okay. Yeah, because it's getting late, right? Yeah.
So the talk will now start.
Yeah. So the last one. This is the last one of the day. Yeah, I think like I will be here tomorrow as well. So after this session also we can stay here for like 1 more hour if you guys want. So we can talk about in more details. Sorry, which SoC? So this is mostly Intel, because my team works in Bangalore. They build the Intel-based Chromebooks. So I own the Intel-based Chromebook in India. But we do have a Qualcomm, MediaTek, and AMD base as well. So we primarily work on all the full like the 4 SoC. Okay, so we have all settled down. Thanks everyone. This is more appreciation required for you guys. It's a 7. It is not only 6. So still after 1 hour, I could see this room is full. I got a dream yesterday that only 4 people are listening this talk, and I carry 4 people from my team. They reports to me, so they cannot escape. Right? So you actually made that my dream fail, which I'm like more happy. So in this session, I'm going to invite 3 of my team members. They will talk about specific of the firmware, because in last session we talked about overview of the firmware, different firmware system. We'll not talk about manageability, because for manageability it's a little complicated. We'll talk about application processor, embedded controller, and power delivery, and they are very entertaining sessions going to ahead, because they prepare a really nice session. I met them at least 5 times in Bangalore to review the session, and they are very smart engineers, right? So with that, let me start the session. The objectives of the session is that as you guys are not very familiar of what's a Chromebook, and I could see that you guys are excited that about the Chromebooks, right? So I'm going to give a thoughts about what it takes to build a Chromebook firmware that we call as a Chrome firmware, right? And what's a different firmware we have. I've shown you different flavors of firmware. I'll try to be honest with you how many firmware that we have. It is not 3, trust me. These are 3 primary firmware that my team owns. We're going to talk about that. There are other firmwares and all. So by end of the session, you will have an understanding about the fundamental roles and responsibility of these 3 key firmwares: application processor firmware, embedded controller, and power delivery. And you'll able to do a very basic key exchange between these firmwares and all, right? And gain a confidence where you can go to the Chrome open source, download the project, and try to build the Chrome like firmware for the Chromebook. If you need a Chromebook for the testing and all, let me know. I can definitely help some way, right? I can try my best to send some Chromebook, or you can come to Bangalore to collaborate with us. So what is firmware? I already told in the last session, whoever joined, right? I don't want to, like, I can't be that animative like my last session, that as per the IEEE standard, IEEE claim the firmware as a tiny and read-only. That is not the case today. Firmware is a very much essential that we have seen in last session, which performs the hardware initialization to hand over the control to the operating system, right? This is a typical job of a firmware, right? And why, as a Chrome or as a Google, for us, we should be interested on Chrome OS, right? Why we're taking interest on firmware, like why firmware is special for us, right? First thing first, I think one of the person asked, right, how many different SoC we work. That's a very solid question, because when you work in the different SoC, you definitely need to change your firmware, right? But when you have a standard firmware, it provides you the interface. That interface I was talking about, Codeboot. Codeboot provides that interface, so you can seamlessly work on ARM, maybe x86 and all, right? It provides the specification. This is what I was talking about. Codeboot provides the specification. Whereas if you go to the U-boot and all, it is a little bit of heavy with the maintenance side. For example, I am working on the Intel platform. Tomorrow I may work on the different platforms and all, right? So for me, the seamless transition is also very important. So firmware provides you a consistent behavior across architecture. Second, it provides a flexible interface to communicate with the operating system. Third, it's a close to the firmware, close to the hardware. Bug fixing in hardware is very difficult. Whoever works in the hardware, they know when we go close to the productions and all, it is very difficult to get a hardware bug fixes. So applying workaround in firmware is very easy, because it is something, as I said, right? Firmware is the soul of a hardware, right? And very important thing, which I tried to tell last time as well, that when you are in application layer and you try to access the ring 0 layer, what will happen? This happened, right? So it's important for you to secure your entire stack. Forget about the firmware, right? It's very important. Firmware equals to security. Modern days, people spend more time on securing the firmware. And this is an overview of the firmware that we run on the Chromebook. So on this Chromebook, we run 15 firmwares, right? We're going to talk about only 3, and it's scattered. We are going to talk about the EC, power delivery, and we're going to talk about application processor. 3 we're going to talk, because talking about firmware may take a year, because you understand it's a full syllabus. I spent maybe around 11 months to write my books. right? And maybe a one year study of that, right? So firmware is a big topic, but you understand it runs tons of firmware, right? So this is the architecture at a very high level. I will take this is a animation, so please bear with me. This is a stack of a Chromebook firmware, right? And we have first source of truth, that's a hardware, and we support all leading SoCs, Intel, AMD, MediaTek, Qualcomm. Then we have a special security key that is designed by Google, right? That is a Google security chip. Mostly, I think you might know about Titan chip, right? That we run on the Pixel phone and all, right? So that's a security chip, and that is our root of trust. Then embedded controller that is basically provides you the very basic operations and all that that Javik will talk about here. And this is running Zephyr, another open source. So here, when you see O, that is open source. Then we also have something called power delivery that is integrated with the EC firmware as well, that performs all your Type-C port. And when you use laptop, I think most of the people use Type-C for your phone charging, for your laptop, everywhere we use Type-C. That is also open source firmware that we use. Then code boot, there is our boot firmware, and this is also open source firmware. We have only one closed source firmware, that's a silicon code, because silicon companies don't prefer to do the open source thing, right? And then we have a depth charge as a payload. I just told maybe last session that payload is a special firmware that is meant to boot to a operating system. So to boot Chrome OS operating system, we design another open source payload, which is depth charge, right? So let me now introduce my team one after another. So Javik going to talk about maybe the embedded controller. Javik, stage is yours. Thank you.
Thank you guys for being here this late. Clap for you guys. So, yeah, I think, have anybody ever heard about embedded controllers? Yeah, I think not. Okay, so for the first thing that you do when you get your laptop in your hand, it's brand new, packed, you open it. What's the first thing that you do? Press the power button. How do you think that gets detected? Something needs to run, right? It's powered. It's not even powered on at the moment. So another question: what happens when you type with your keyboard? Another thing that I want to mention is like, how does your USB connection get managed? What happens when you connect the USB to your laptop? Does it go through something, or is there something that it comes in the middle before it goes to the CPU?
You understood which one I prepared for you?
You don't need to get your CPU on for that.
Reverse pyramid.
Do something like does this. So here comes your embedded controller. To just introduce, in Chromebooks, we typically use an ARM Cortex M4 based processor. And just to give you an idea of how small that processor is, it's just 512 GB of memory. So that's your secondary storage kind of thing, right? Just 512 GB, 64 GB of RAM, and it runs on 48 megahertz. Your processor runs on gigahertz speed, right? 2-3 gigahertz of speed. And I don't know if you guys know GPIOs, but these are for general purpose input output pins. These are all just pins that can send some voltage on your from the other devices. So to communicate. And what we have in the flash on the EC is an integrated flash. So unlike your CPU, where all the storage, like the hard disk, your SSD, and all that, everything is outside from where the OS loads. Inside in the EC, in the case of EC, it's all inside, right? And a RAM as well, in the same SoC. SoC is the system on chip, and everything is inside the same SoC. Now, what I think I just asked a few questions, right? How does all this work? Okay, so EC has a few peripherals connected to it, and whatever we, in terms of like microprocessors or something, it's called microcontrollers. Okay, and that controller we work with different vendors and everything to get all the inputs and all that stuff. And just want to think about this is just about the laptop, right? You can also think about what happens in your phone when you press your power button. I'm not going to answer that, but you can think about it. And also in servers, I think Subrata mentioned all this, right? In servers as well, there is something called board, EMC, something like that, right? For a management controller. How does that work? I think you can. I just want to keep it open for you guys to explore. But on the laptops, let's just discuss about the laptop, right? So what does the EC do? You press power button, it detects that to the GPIO. As I just mentioned, right? It detects signals. Whenever you press a power button, it just closes the circuit with a 5-volt input, and it will just boot. It will just boot itself first, and then it has to boot the CPU. because the CPU is off. You have to first boot that, right? You first boot that with a startup sequence, and as I said, this is something very specific to all SoCs. It's a very different process, and you can think about it. And we have peripheral management. In Chromebook specifically, we have all volume buttons as well. I think Windows usually don't have all these things, but in Windows we have this, and as well as whenever you open your lid, right, it needs to be sensed somehow. The lid got open. It needs to be communicated to your CPU. So all that is also managed by the PC. It's a small controller that's working in the background all the time. So also there's a keyboard controller called, and it takes your keyboard matrix input. So what is the keyboard matrix? Just a bunch of wires connected here and there. Whenever you press something, it just puts it just closes the circuit on a bit basically. So it can detect all the buttons that you just press. And thermal management, right? All the processor's temperature, the CPU's temperature, and all that is going on all the time, right? And it's going to increase. We have to control that as well with a fan. Right? Usually we have fans in our laptops, so that is also managed by your temperature controller. And I think there is one more session by Pranav, and he will just talk about how we charge our battery, right? Because in Chromebooks, primarily we want to use Type-C ports, basically. So we have some manageability code called TCP-M in the embedded controller that takes care of all this management, and Pranav will discuss in depth about all this stuff. Yeah, and as Subrata mentioned, we love open source. Okay, everything we do, we try to get it open source. This link that I'm just showing here, whatever code that I'm writing, you can go there and blame me if I'm writing that, right? You can just go there, it's all there. Okay. Previously, before before that, we just had a few years back, I'm talking about. We didn't have this open source thing in the embedded controller. We used to have our own in-house built RTOS. Okay, so that's called the Pro Cross RTOS, which had a lot of problems, and it's a non-technical reasons, right? It's not just technical reasons why we want to be on open source. So we try to get something from the open source community. But I think you have heard this throughout your session today. This is just a real-time operating system. Real-time means everything happens right now. It's not like a GPOS on your Linux and that takes time to write. So it all happens right now. And what we did was, so on our legacy EC code, we just put a shim layer. It's called an interface layer between our Chrome EC and the Zephyr RTOS. We just ported all the APIs, and we now enjoy the features of all this. All the EC. So I just want to go through all this, right? So in our RTOS, limited features, we have to implement all the features, and we even have less firmware engineers, right? How to implement everything. Limited number of community contributors, and Google has implemented everything. And vendors, right? Basically, we work with a lot of vendors, and they have their drivers, right, for everything. So all these vendors can directly just contribute everything on the open source forums, and we can use it as is, right? And a lot of security vulnerabilities get resolved because more eyes, better security. And useful frameworks that we use from the Zephyr source is the device trees, test framework, and everything. I'm not going deep into that, but it's very fun. Right. So let's go through the boot flow. Right? I said we press the power button first, and I just lied to you that I said it goes to the EC. No, in our Chromebooks we want security. Security is the primary thing that we want. We have something called as GSC, Google Security Chip, that detects it. Even the power button that we press is also detected through GSC to ensure we are secure. Right? That input goes to the EC, it resets everything, and then there is something called as PCH, Code Platform Controller Hub, that is very Intel specific because we work on Intel, and that boots the CPU. Right? And now my very capable colleague Dinesh will get in depth with everything about how we boot till the OS. How do we go till from OS comes, right? So we have core boot in the middle, depth charge, and we have the Chrome OS. Right? So I'll hand it over to Dinesh. Please.
What kind of security threat are you looking into this after power button gets it?
Good. I was expecting somebody to ask this. So actually, we have something called a recovery mode. Okay, and it has some.
Too late. Yeah.
we have something called as recovery mode, which Dinesh will talk about, and it's very critical because we use power button to go into recovery mode, and there are some security vulnerabilities that can be introduced if you let and open vendor code like EC's code, right? So sometimes EC is not always implemented by us. EC sometimes is also implemented by the vendors, and we don't want our security to go out of root of trust, right? So that's why we keep everything in the GSC, so that even for power button detection is also by GSC because it's our trusted. Yeah.
What happens if your home book in a coffee shop and when you wait for a wash? Somebody asks you from like when you are not there. You allow to boot with a compromise number? No. That is where your GSC will be there.
Yes.
The last firmware, this one is not good. So I'll say your system is compromised. I'm not going to boot your machine. But return the machine to the factory. They will recover the machine. That is the quality. It's similar to Android's recovery mode. No, Android recovery mode
is different. Yeah.
You are going to a post-trial environment. But never try to crash third party on there. Yes. So the Android. Yeah, I understand. But what I'm saying is that at least when you run the Android third party code and all, you are still actually booting. But I'm saying this won't allow you to boot anywhere. You stop at the reset. It will not allow because your platform does not run any version of code. What you are saying is it will allow and it will not allow to the OS. But one saying that it will not allow to run any component from it. It will stop. Say machine component. I should not run any code. So, yeah.
The mechanism that we are discussing here, that JC implements, that also pretty much exists in all other core vendors that we're using that you see in our. Because many of those silicon are being used in surplus.
Correct. Yes.
Essential factor.
Yes. Yes.
So what were the design choices which led people believe that a GSC approach is better than vendor provided root of trust?
Yeah, I think Sugata wants to answer that.
Yeah. So give the uniform as you like answer yourself, right? Yeah. When you go with a different system method, I cannot identify, I cannot control, and you have to lies on their source software. Right? They have to tell you, oh, this software is secure. How should I know? How should I audit it? Rather than we rely on our software. And we say we audit our software. That's easier.
Yeah, this is the root of trust for us basically. So everything boots from here till the last thing. That's what I wanted to emphasize. Yeah. Yes, everything becomes uniform because yeah. Yes. Yes, yes, true. Yeah. Okay, I'll just hand it over to Dinesh now. Thank you. If you have any questions.
Jay, can you please help me? Oh, it's fine. Am I audible? Yeah. So the magic happens when OS boots. So when OS boots, we can do anything. Like we can watch videos, we can play music, we can surf the web, we can play games. But can we do it right after when the EC initialized? No, there must be something in between. And there comes the application processor or CPU. So the firmware that execute on it is called application processor firmware or AP firmware. The goal of the AP firmware is to boot to the OS with minimum hardware initialization. So let's talk about different components that builds the AP firmware. One is core boot that does the minimum initialization, and it handed over to the depth charge that actually boots the operating system. We have a security mechanism that is called verified boot, and we are going to discuss in coming slides that in depth what exactly these things are. And apart from this, we have something called silicon firmware that is provided by vendors, and it is not open. So a vendor actually decided to not to disclose their code. So it is integrated with the core boot and builds. So core, let's discuss about a bit about core boot. It is again open source, and initially it was developed by Ron Minich back in 1999. That time it was called Linux BIOS, and the motivation was like he was thinking, why I have to go to all the PCs in the lab and press F1
to boot it. So he wrote the firmware for that, and that's how the code was started. So back in 2008, Stephen Renor, when he becomes the maintainer of the core boot, he actually renamed it to the core boot. Core boot is very simple. It is written in mostly in C. 95% of the code is written in the C and assembly. It is actually not a bootloader. It initializes the hardware and handed over to an entity called payload. So payload actually boots the OS. It supports various payloads, and the payload for Chrome OS is depth charge. We are going to discuss depth charge details in coming slides. A few things about core boot. Speed. So core boot does a minimum number of initialization. So that is required for the OS to boot. So that means that translates to a fast speed. Then comes the security. So we are like very much concerned about the security. So there comes the verified boot. We are going to discuss about in the coming slides. And simplicity, it is written in C. We reuse as much as possible. So the code is very small. So that's why it's very simple. And generally the firmware code, the low level code is like complex, but here we have a community driven documentation for everything. So everything is auditable. So it's very simple, and it is open for vendor, open for users, open for students, open for developer. So anyone can use it, modify it, and play with it. So when we talk about the security mechanism, how exactly it does. So it actually establishes a trust of chain. So if we divide the core boot process into multiple phases, okay, so multiple phases or stages, so each stage will actually verify the next stage. So this foundation actually start with root of trust. Root of trust means it is there in the read-only firmware. So read-only means it is always it cannot be altered once it is flashed. So once it is there in the factory, we'll flash it and no one can change it. So it will always be true. And post that, it has the key, and it is actually hardware locked entity called TPM, trusted platform module, that actually has the ability to lock it and to secure it. So RO firmware, actually it has everything, like it is trusted. So it verifies the read-write firmware. That is the next step. Read-write firmware is something we update whenever something updates comes. We change it so over the time. So once read-write firmware is actually verified, it verifies the kernel. So once we know that kernel is trusted source, so it verifies file system and we boot to the OS. So this is our trust of chain. Now talk about depth charge. Depth charge is again a specific payload for Chrome OS that actually boots the OS, and it is again open source and designed to boot Chrome OS specifically. Its goal is boot Chrome OS as quickly as possible. So there are few offering depth charge does. It initializes the storage driver because OS will need memory to keep running. It initializes TPM. TPM, I already discussed, is a trusted platform module. You can think about a vault. It has all the keys and some secure code. We need sound drivers. So DevTar does this configuration initialization. We can say DevTar does the graphic engine, means graphic initialization. DevTar also support the Android fast boot. Android fast boot is something that debug and flashes the Android. So DevCharge kind of a bridge between Android fast boot and OS. And we need a console. So DevCharge actually initializes a debug cell. So once the OS is up, if something vulnerability happen, then we can check actually in console. So we need a console as well before the OS starts. So what exactly DevChat does after the initialization, it chooses the kernel slot. We have different kernel slots and jumps to it. For that, we have different modes, verified mode, recovery mode, and developer mode. We are going to discuss these things in depth in coming slides. So let's have a case study of Intel SoC. It is a CPU 12th generation heterogeneous processor. If you see in the block diagram, we have multiple cores, so that's why it's heterogeneous. It has multiple peripheral attached, dual channel Hynix, some 8 GB LPDDR memory. So if you see in the diagram, there are some DIMM attached with the RAM, with the DRAM. Some USB components are there as a peripheral. Some low power subsystem attached. If you see somewhere here, TPM and CPU debug here. And display, embedded display should be connected, so we can see what exactly happening in the system. And some storage devices, secondary storage device, and NVMe we have here. So the purpose of this slide is like which all the components will be initialized at what phase. So let's divide this initialization process in 3 parts. First is pre-memory initialization, because once we start, we don't have the memory. Like we have the memory here, but it is not configured, it is not initialized. So we have to initialize it first. So that is called pre-memory initialization. Then memory initialization, like we have to do the memory initialization. And post that, we have the memory. Now what we are going to do, what we have to do to boot the OS. So first, pre-memory initialization. If we see the diagram, the gray one are like inactive, or it is not enabled yet. So you can see the DRAM here, it is not active, so we cannot use it. And the green one is active, so only 2 things are open: core, so that is a processor, one of the processors is active, so we have we have to process, so we need this thing. And one more thing is here, SPI flash here, this thing. So this has the core boot code or firmware code and silicon binaries here. So apart from that, a few things we are going to initialize here. If you see in the blue one, that is going to initialize before memory in order to initialize memory. So first thing, without memory we cannot work, so we need something. So we'll be using cache memory here. So if you see in middle of SoC, one thing, temporary memory. So temporarily we'll use cache as a RAM. So we'll call it CAR. And few things, SPI controller. So we can communicate with the SPI flash, so we can get the firmware code. And I2C controller, so that actually connects to the vault, so we can verify everything. This is our vault. This is how our secret key store. And we have UART controller, so we can have communicate with the CPU debug, and we can have the prints. We can have the console. So CPU comes out of reset and start executing from the core boot that is there in the SPI flash. Somewhere here we start reset vector. The first thing we do after you see. So first we have to do the setting up the temporary memory, that is CR, cache as RAM, because we don't have the RAM. And early initialization of boot critical devices that we already spoke, like cache as RAM. We need to talk to SPI flash, to SPI controller, some security features we have to talk this, and the console. So in this phase, we have initialized this, and we are moving to the memory initialization phase. So if you see in the green, the TPM has been initialized. We have SPI controller in place. Cache is working as a RAM, and UART controller. So if you see in the blue part, we are right now initializing the DRAM memory. So this is our RAM. So the DIMMs are kind of bridge in between the RAM and the motherboard is connected. So it is called ROM stage because we are still not in the RAM stage. Still not in the memory. The core boot performs basic hardware initialization before calling into the silicon binary APIs. load and execute DRAM memory init APIs. So like it will initialize the memory here. Core boot create CBMM based on DRAM test resources. CBMM is like core boot memory, so it will initialize the memory, and a part of it it will use for the processing. And post that, once the memory is there, we will migrate to the DRAM. Like we'll copy our code to the DRAM, and from now on, for security purpose, we are not going to use any other thing. Like we are not going to use the SPA flash. We'll be using memory only. Memory means RAM memory. So now our memory has been initialized. So we will initialize remaining things like the peripherals, external display, type C subsystem if you want to connect something here, storage, secondary storage, these things, and other code. If you see in the blue color, all the remaining blocks, different cores, display, USB, storage, we are initializing it after the memory initialization. And this is called the RAM stage. So what makes the Chromebook different? This is our path, how exactly we choose which mode we are going to boot it. So we already discussed, like we have different modes, verified mode, recovery mode, and developer mode. Let's discuss about it. Verified mode is also known as secure or normal mode. So if everything is happened, we verified that our trusted Google signed OS is working, then we are saying we are secure, we are in secure mode, everything is fine. So we can guarantee security, so we are in verified mode. If something happens, like some abnormality happened during the verification process, so we have to recover it. That's where the recovery mode comes. So whenever some abnormality happens, like verification error during the process, or maybe corruption of some images, like RW image is not correct, or some hardware issue happens. So you will see this screen. You are through the recovery process, like we are not allow you to process further. We will not allow you to boot to the OS because OS is compromised. So what we will do now? So hardware, if it is hardware issue, we cannot do anything. But if it is software issue, so we can recover it, and there are different means of it. Maybe like if you have a USB drive, so we can actually download Google signed OS and flash to it, and like boot to it. And if you don't have this one, we can use network based recovery. So we'll actually connect to the network and boot to it. And the last is developer mode. It is like for the enthusiast. If you want to like play with it, so whenever a developer mode is done, we actually stop the kernel verification. Kernel verification means we are not actually verifying it. So you can flash a different OS, your modified OS, like you can download and you can change the OS and you can flash it. So that's why the developer mode is there. So as we are like, it is not kernel verification off. So every boot process will getting a developer warning that you are at this mode. So to go to the developer mode, physical presence is required. It's like we should not someone from the remote should not be like going make your device to the developer mode. So physical presence is required. That is confirmed through a trusted source, like some power button or something. And it is used for debugging and some advanced thing if you want to do it. So how to go to this developer mode is whenever we are in recovery mode, just press Control D. So that's it from my side. Thank you. Any questions? Okay. Oh. Yes.
Sure. Yeah, no problem. So I'm going to talk about the USB power delivery. So maybe asking who knows about USB is a wrong question. So how many of you know about USB power delivery and what it does? Good, like 2 people know it. That's great. Yeah, 3. So I'm going to talk about what USB power delivery is and how it has improved USB in a way that now it has become really universal. Right? I'm going to talk about that. So first of all, I'll start with like why USB and why USB PD. How many of your laptops look like this right now? If yes, please change it. Okay. This is not how a laptop should look like right now. So at least even if you guys have not seen a laptop like this, you guys have used the chargers like that, right? Barrel connectors. For every vendor, every device, there is a separate charger. It feels like it's almost connected but not charging. Some are not connecting at all. There were so many problems. So USB solved this problem of a lot of ports and connectors. USB power delivery is solving a problem about charging the device, as well as it is adding a value addition to the USB protocol itself in a way that it has increased bandwidth and so on. So I'm going to talk about that as well. So very basics of USB, I'll just quickly glance through it. So USB is an industry standard which defines cables, connectors, ports, communication protocols and whatnot. So everything is covered by the protocols and specification. So no, whoever is implementing this need not worry that whether it will be operational with some OS or some hardware. You need not worry about it. Everything is covered by proper specification. So it is published by USB Implementers Forum. They also provide certification and testing platforms so that the interoperability is ensured. So few terminologies, USB Type A, Type B, and Type C. These, when I talk about this, these are just the physical connectors. And USB 1.0, 2.0, 3, and now 4. These are the protocol revisions. And USB power delivery, although similar to these other protocol, it does not directly link to the data communication, but it helps it in a way. I'll talk about that. So quickly, evolution of USB. USB started back in 1996 with full speed, USB 1.0. Just follow the data rate and power here. It started with 12 Mbps and 2.5 watts. At that time, they thought it's like, okay, full speed. Nothing can beat this. Okay, then came USB 2.0. They somehow managed to name it high speed. Okay, fine. The data rate increased to 480 megabits per second and power remained the same. This was enough to power almost all the peripherals that were used back then. So it was still fine. And later came USB 3.0. They kind of improvised and named it super speed. Data rates jumped to 5 Gbps. Now it supports all your good cameras and all your displays and all whatnot. And the power still remained the same, like almost 4.5 watt. From 2.5, it was a slight increase. So USB 3 had a lot of revisions. Towards the end of it, it reached a point USB 3.2 Gen 2 Cross 2 Super Speed Plus. The data rates reached up to 20 Gbps. Here is where the USB-C helped this, right? So I'll talk about the pins and everything. Then you'll realize how the bandwidth got improved with this. And then power. If you observe the power, it was 4.5 watt. Suddenly now you can supply 240 watts of power through the same USB port. It needs USB-C, but yeah, through the USB you can support that. So how it's achieved, I'm going to talk about that, which is the USB power delivery specification. Right now we also have USB 4 with increased data rate and power still remains the same. Right. So what's the main advantage of using Type-C connector? Can anyone guess or tell me? Like you guys have used the legacy Type-C and yeah, of course, that's the answer I was expecting. Of course, I just told you that bandwidth got increased, power level increased, but still we care about like symmetrical and like flipping orientation and all such things, right? So yeah, you might have seen the connectors, but this is how the lanes or the pins look like. So if you observe, A1 to A12 is replicated from B1 to B12. So either ways, however you connect, it will still route the lines properly. So behind the scene, a lot more goes on. So let me just explain briefly the lanes, right? By the way, all the USB spec is like backward compatible. So USB Type-C, USB 3, it backward compatible with 2 and 1. Of course, nobody uses USB 1.0, but it's still backward compatible. So yeah, this D plus D minus lines, there are 2 sets of them. It's used for USB 2.0 functionality. And VBus is, of course, to give power. And then CC lines, right? Configuration channel line. So this is used by the USB power delivery protocol to speak to the port partner and enable that 240 up to 240 watts of power and higher bandwidth, right? This is the lines involved to do the protocol negotiation. So then comes the USB 3 lines. Of course, there are two sets of them, TXRX lines, and then sideband use. I'm not going to talk too much about this, but again, this is also some line. Okay? Now, USB power delivery. So what is this? It's a specification that enables maximum functionality of USB using the Type-C connectors, right? All of the pins got replicated. So now what do we do with that? If we just use it just for the flip, of course, it might not be that useful, right? So what they did, they came up with some power delivery protocol so that it can use maximum of those pins to deliver maximum bandwidth as well as power, right? So some of the features, of course, the protocol communication happens over the configuration channel lines, and then bidirectional power, right? So if you have ever wondered why your legacy cables, USB cables, had a type A at one end and type B at the other end, right? Because the power was fixed. So the type A could only source power, which was received by the type B side of things, right? So, but now with the type C connector and power delivery, this is no longer fixed. So you can switch between being a source and a sink. So when will this be helpful? When you connect a laptop to some other device which was not powered by then you can source the power. Once it gets the actual AC power, you can actually sync the power and charge your laptop. So that is where it will be useful. Again, on the data side, it can be bidirectional. Same applies. Whatever I told for the power is applicable for the data as well. And then supports different voltages, 3.3 volts to 48 volts, and different currents up to 5 amp. When I say 240 watt, it's not like 0 or 240. You can do anything in between. And it also supports something called as alternate mode. So Thunderbolt, DisplayPort, HDMI, you might have heard about all these protocols, but now we can pass all these through the Type-C cable, so which is enabled by the alternate mode. So here I wanted to discuss about few messages that were involved in the USB power delivery source capability. So if you see this is a charger adapter. It says the output can be 5 volt, 3 amp, 9, 12, 15, and 20, and 3.25 watt. So now we get options to choose power from. So this is advertised by the source capability message, and the sink will request for a particular voltage, whatever it needs, whatever it suits its system, and then data role swap can happen. And this accept and reject messages is for like when you give a request by sink gives a request to the source can accept it, or if it can't do it at the moment, it can reject it. And then discover identity, this message is used for the alternate modes that I was mentioning. It helps knowing the a port about its port partner more, what alternate mode it supports and other things. So then the enter and exit alternate mode, this is a particular message. And then good CRC. So good CRC is one message where all these other messages by the port partner are validated to see that it's received error free, and then a good CRC message is sent back to the sender of all these other messages. Right. So now let us see in a block diagram wise like how it actually works. Right. So when you have a laptop Type-C port and you connect a USB 2.0 Type-C pen drive, so what all will happen? I hope you remember the pins that I mentioned earlier. VBus is there to give power, CC lines for the connection detection as well as the PD negotiation if needed, and of course we have our legacy, the USB 2.0 D plus D minus line. So first, when you insert a pen drive, it is detected, the insertion, the connection itself is detected by the PD5, and the CC logic will enable a switch which will power 5 volts, which will give 5 volts, right? So now the pen drive gets powered. After that, your usual USB enumeration happens. Now with USB 3.0, it's almost the same. So connection is detected, power is enabled, and instead of the D plus D minus, now we have basically a mux for the super speed, and it will route the write lines to the super speed 5. And now what happens when you connect something more complicated like a monitor, where you have to charge your thing, you have to charge your laptop, and then you have to send some DisplayPort data over it, right? So now much more pins are involved, but the fundamental remains the same, right? So initially connection is detected. Now instead of sourcing power, we are syncing power, because monitor, assuming that this is connected to the AC, can now charge your laptop when you have when you're projecting something over the thing. So two things can happen at the same time. So initially we will get 5 volt as soon as we connect, but if we want higher voltage, right, and or higher power, here is where the power delivery controller comes in, and it will ask for the, so basically this would have published some, I can supply this power, so this can negotiate the power and get the power that is needed. So that can go up to 48 volts. And then the mux is enabled at the end. So basically one more thing, right, after this, since it's a display port, we need to get into the alternate mode. So alternate mode is also negotiated. Hopefully from the last slide you might have known all the messages involved. So there's a lot of back and forth to understand each other, understand the port partner, and then like come to a conclusion, and then the mux is enabled so that the right lines go to the right pins on the SOC. Right. So what's the role of TCPC? So basically, yeah, what's the role of TCPC and TCPM? So this is our Chrome implementation of the USB power delivery. So we have divided power delivery into something called TCPC and TCPM. So TCPC is the Type-C port controller. So what it does, it will just provide you the PD physical layer that is needed, and then all the intelligence is handled by this part. So basically, yeah, it's a dedicated IC for the PD layer. It exposes necessary termination based on the power role, and it provides physical layer to send and receive the messages that I was mentioning, and validates the CRC as well. And then Type-C port manager, it is implemented as a part of EC. Jaivik has talked about EC in depth, so this is part of EC itself. So it interprets the messages that this guy has received, and it will try to frame a valid response and try to make the negotiation happen, right? So again, the connection detection, and it advertises its ports capability, and it implements some device level policy management, and then it exposes a communication interface for the AP for OS level management. So the idea is that we should not disturb AP unless it's really necessary. So EC and all these things should take care so that your main SOC, whatever Dinesh explained, is free to do the actual work that you care about. Like it can run the actual application level code, right? So this is my last slide, by the way. So I want to conclude with where you can find the source code for our Chromebook Type-C PD implementation. So you can find the source code in this particular slide. It also has a link embedded. If you get hold of the slides, you can just go there and just have a look at it. So it's a state machine based implementation where device policy manager layer and policy engine protocol and Type-C layer, they're all in a separate file, so that it's not messed up, so that you don't understand what code it is. So it's all properly classified so that you can have a look at it, right? So with that, I would like to conclude. Thank you. Anybody has any question? Anything particular about Chromebook as well as anything in general about USB PD? Yeah.
I have a pretty old Chromebook. Like I went through, integrating printing Chromebook and the Chrome OS. Like it's probably in the year of 2017.
Okay.
So will I be able to upgrade it to the latest firmware, or like?
Yeah.
So right now the policy says that you can update till 10 years. And you can correct me. Like which device is that? It's an ASUS. Yeah. So will it be compatible with the hardware? Like we support like till 10 years now. And there is a communication team maybe last year in the Google I/O. We are supporting 27 for sure. It is support. If you face any issue, I'll share my card with you. Let me know. Because we have teams are working on this. I want definitely support because they are interested in oh, so I'm still working with your team. Like during that point of time, initially was BTP, and then
Are we still
started integrating
streaming?
I guess we are. I have tried to connect because there was change in the all structure. There was one guy on earlier. I I think so far you now well, I was thinking that I should correct you.
So this was the first day of our conference, and so I hope you all liked it. All the sessions we have. We will tomorrow stream again, and so I will end the streaming for today, and we will see us tomorrow.